Work it out.
C'est rouge, c'est activé.
Hello, hello.
Hello, hello. Okay. Hello, everybody. We are now starting the first paper and talk session for this conference. The topic of this session is about web audio creativity and influence. And the first presentation is from Otto Rotier, coming from Utrecht, Netherlands. He is data engineer at Rijksoverheid. And he works with Benjamin Matujowski, working at IRCAM SMTS, Sorbonne Université, Paris. So it's for you now.
All right, thank you. I'm very happy to be here. As mentioned, I don't really have a background in audio, nor academic, nor industry, but I do have a background in physics, so I might. It's very helpful in audio processing. And the company you mentioned is actually the Dutch government, Rijksoverheid, where I do non-audio stuff. But Benjamin and I did some work together, and our talk is called A Rust Implementation of the Web Audio API. And maybe the subtitle is even more important, Decoupling the Web Audio API from the web. And I hope in this talk we'll explain a bit how we're going to make this pie slightly better that Hongchan mentioned by moving away from the web. So first, let's assess what the web in the Web Audio API means. It's available in the web browsers, obviously, all three of them. You interact with it with JavaScript, and of course, you get full access to the browser's DOM, the audio elements, the media elements, basically the whole user interface. And then there's this neighboring APIs, such as WebRTC, media devices, media recorder, that you can leverage with the Web Audio API. But mostly, the Web Audio API is just an audio processing engine. It's an audio graph. It's well documented, easy to use, and extensible. And it enjoys some popularity. There's a conference going on, and we're all here. And our point is that the coupling to the web is not extremely tight in the Web Audio API. So why don't we just build an implementation from scratch with no web involved? That's great. A bit of reverb. I like it. So that's what we set out to do. And then the ultimate goal is to open up for new platform and application areas. I'm going to show two demos, which are command line tools actually running Web Audio API. But you can use it for desktop games, embedded hardware, or just tiny hardware where you don't want to involve the whole browser. And you can do scene pre-rendering, basically everything the offline audio context gives you without a browser. And then we widen the community outside of JavaScript. So our journey begins. We've read the specification really well. It's over 200 pages. It's quite a nice spec. It's the first spec I read. And we looked at some prior art, most notably the Lab Sound project. It's a C++ implementation that was forked from the original WebKit implementation, but it has since deviated from the spec. Still interesting to look at still. And then there are some academic exercises in pure JavaScript and Python experiments. And well, for fun and giggles, we decided why not build it from scratch. Of course, we could have also ported the existing browser implementations, but it's less fun. So if one of the first commits is in January 2021, where I'm scaffolding the audio context, which is quite important, as you know. And then let's have a look at the end result. This is a snippet of Rust code, and it should look really familiar to you. There's some import statements, you can forget about it, but basically we're setting up an audio context, and then we're setting up the audio graph. There will be an oscillator with a frequency of 400 Hertz. We ramp it up in volume and tween it back down. And then there's actually a cycle in the audio graph for a feedback effect. So this is Rust code. I'm going to run it now in my terminal, and it's interacting with the Web Audio API. It does look a tiny bit different from your JavaScript code, but there should be no surprises. Let me try this out. Should be right here. So here's the file again in my terminal, and I'm going to run it to show you that this is not just an academic exercise, it actually works. So this is the 400 Hertz tone with an infinite feedback cycle. Well, it's not too spectacular, but I hope you do realize it's the Web Audio API running outside of the browser. So why did we choose the Rust language? Because we want to jump onto the hype, of course. But actually, it's a language that is living up to the hype. It's a system language, much like C++. It's very low level. There's manual memory control. You can avoid garbage collection. And it brings the unique concept of data ownership to ensure at compile time memory safety, thread safety. There's no runtime overhead in the language. So we're fighting the compiler regularly, but it does ensure a smooth operation at runtime. And also it's very friendly for foreign function interfaces, so we can bind our core implementation back to other languages, and I'm going to show an example of this later. So the appeal was that it's very similar to C++, the king of audio processing languages, but it's not as daunting. It's a smaller language. It's very beginner friendly, has mature tooling. Adding packages or dependencies is very simple. And over the past few years, the ecosystem is really maturing to do cross-platform, high-performance audio I/O. It's very simple in Rust. The decoding libraries are maturing. So this was the right moment to start. This is a small overview of the architecture of the library. This should be no surprise if you've ever built an audio processing library. There's the notion of the control thread and the render thread. And the render thread has the sole purpose of shipping samples in time to the hardware to not cause any hiccups. So the audio graph where the nodes live topologically sorted, they're all in a render thread, and there's a callback which is running every millisecond or so to ship 128 samples to the hardware. And we, the community, we write our user space application with all the nodes and the contacts, and that is on the control thread or the UI thread, as you may know it. So what's the current state of our implementation? Most of the spec is implemented. There's a few nodes missing, but I think of the API service, we've implemented the big majority. As you saw from the code snippet, we did have to make some concessions to adapt to the Rust code style. And also Rust can be inherently multi-threaded as opposed to JavaScript in the browser. So we had to make it thread safe. And another hurdle was that there's no object-oriented concepts in Rust. So we had to introduce getters and setters for some stuff. Method overloading is a bit different, and we're using composition instead of inheritance. So there might be slight differences, but we've put a lot of effort to make it look like JavaScript code. So for us, the easy parts in implementing was the control UI thread, audio graph traversal and rendering. You need to sort the nodes to make sure they render in the right ordering. To do cross-platform high-performance I/O, implementing the nodes. There's 3 left. I'll mention them later. Sample accurate timings. And a nice thing about Rust is that there's no concept of acquiring the content necessarily. This is a part of the spec where you ensure unique ownership over audio buffers when you start rendering them. But Rust at compile time will verify this for us. It's really easy. The hard part is, of course, when the specification is hitting the boundary. So it's going to interact with DOM elements or neighboring APIs. And we need to come up with some simple shim to deal with it. For example, the media stream. We had long talks about how to compact it to the core thing that a media stream is, because there's no such thing as a native media stream in Rust. Then, of course, there's promises in JavaScript code. We need to map them to async primitives. It's not always hard, and there's a lot of work to do there. And the Web Audio API also has a lot of stuff around event handling, attaching handlers, and bubbling up. There's no native Rust translation for it, so there's work to be done. I just want to give also the example of the media element source node. It's a very simple node. You connect media into the graph, but there's so much behind it because a media element can communicate over the network or disk. It does buffering, seeking, reverse playback, pitching. We needed to implement a big chunk of all that. And of course, all the other audio stuff that is generally hard is also hard for us. Convolution in real time, anti-aliasing, head-related transfer functions, graphs in your audio graph. So I want to dive into the performance part. The render thread obviously has to keep up because we're emitting audio in real time. So we've taken special care not to use any locks, just atomic operations in the render thread. So there's no danger of priority inversion by the operating system. We generally try to avoid allocations and deallocations as they might take a lock on the global allocator and also lead to priority inversion. We're writing single instruction, multiple data-friendly processors, so you can use on a single core parallel execution. And we're preventing duplicate work if an audio stream is upmixed to an identical 2-channel signal. The render quantum design is planar layout, float values, 128 of them. Reference counted, so they allow for upmixing or splitting easily. And we're using an allocator that allows to reuse the buffers. Then the ugly parts, we've taken a look at the semi-official benchmarking suite of Paul, where we compare the Chrome, Firefox, and Rust version. What we're noticing is that we're being a bit slower, 3 to 6 times. So this is something that we need to divert our attention to. I think we can do a lot better. We've worked mostly on getting to feature completeness, but now it's time to look at the performance and also just steal from the existing implementations any tricks that lead to better performance. Then I will show a small demo that we've bind our library back to Node.js so that you can run JavaScript outside of the browser in the terminal. And the deal is that you then just write your audio code once and you can run it in the browser or in the command line tools. And officially, later we want to run the W3C test suite to check if our library actually does the right thing. It's written in Node.js. Show a small example of this. Again, it's a very simple demo. Here we see the JavaScript file or the Node.js file that sets up oscillators and it runs a callback every 100 milliseconds to set up a friendly tone. And this is running outside of the browser. This is command line Node. And as you can hear, great ensemble of tones. So yeah, so you don't need to learn Rust to use our implementation. You can just write JavaScript code. So not here, but maybe later in this conference, I can show you a bit more involved example where we're going to capture application sound, whether it's desktop gaming, a conference call, or a live stream, and then pipe it into our library and do transformations or recordings, room corrections, and then emit or record it. So we're really leveraging the power of desktop there. So just like Hongchan shares his roadmap, I'll share mine. It's a bit less ambitious. But we're releasing the version 1 with the stable API soon. We need to work on 3 more nodes. 2 of them have a work in progress. And we need to look at performance and stuff I already mentioned. And of course, we're keeping up with exciting stuff in the web audio specifications, such as variable render quantum size, performance heuristic, specifying the I/O devices. That's it. Thanks for listening. We're very welcome to contributors, users, and criticizers on this repository where we develop in the open. So thank you.
Thank you very much. Is there any question in the audience?
Yes, I have one remote here. Can you hear me? Yeah, we got a question. All right, my question is, what?
Wow. This is my live demo. I also do visual stuff. But I can hear you. Go ahead.
Okay. So you didn't mention this. What about workload nodes and specifically WASM workload nodes?
Sorry, I didn't hear the question.
In terms of implementation of nodes, I think that's a node. What about workload node and WASM workload nodes?
Sorry, I didn't understand the question. Did you hear it? Oh, can you try it one more time? Sorry.
Try it once again. So there's a node called the workload node.
Ah, yes. Okay, I can expand on the workload node. So for now, we're exposing the internals of our library, which is called the Audio Processor API. And it's very similar to the audio worklet. It takes the inputs and the channels and it applies a transformation and it can be run stateful. So we are already extensible in a very similar to worklet node kind of interface. But it's not 100% similar to the spec. So we're actually keeping this option open. But in terms of performance, it's just generally better to use our exposed internal API for extensibility than to actually use the worklet node. But in any case, you can build a stateful, self-built transformer that can cache data and can transform inputs and everything. So that is definitely possible in our API.
Hey, yeah, that is great to have a web audio API out of the browser. There are other web APIs that exist natively, and I think it's great that we could, once you taught or learn the web audio API, transpose this to native codes. It's great. It's a great proof of concept for the web audio API too. I think all is positive. Now, maybe I'm a little too old or something, but I'm kind of angry about this Rust thing. I don't understand that. And your justification seems odd. I would like to hear, in this community, there are a lot of great audio coders that can help us to get this done, or it's the easiest way that you can reuse your JavaScript code you wrote in the web browser. It's the easiest way that we can get fancy features around which are important communities, like the WebAssembly code inside the audio worker thread. That are very important arguments for the choice of the language and the environment you're coding this in. And they seem to miss, but maybe you can.
So the question is basically, why not C++?
No, this is not what I said.
Well, I think it's a fair question, and it also really has an impact on the type of contributors and the growth of the library that we can expect over time. So I'll be honest, I just like Rust. So this is also my learning experience. But to give a bit more broader argument, I have a gut feeling that the current web developers are more inclined when they want to do system level programming to move to Rust instead of C++. So I'm hoping to bring in a web developer community to our library, because Rust, it just looks a bit friendlier and nicer, and package management looks like the NPM package management. So I'm just hoping that these web developers transition to a systems language and they're scared of C++ like I am, and then they write Rust code.
Just a quick question, it will be the last one, I think. Did you reuse any of the Rust implementation from Firefox?
There's interestingly this artifact indeed that there's a half-finished Rust implementation of the Web Audio API. We looked at it, but not heavily. But I think it will be a source of inspiration when we're going to optimize nodes further. Yes, it's a very nice relic that is now on the internet, the Rust implementation.
Thanks. Hi. So Rust does have this multi-threading capability that you said wasn't in the original Web Audio API, but I think that could be very interesting in terms of new applications. Are you planning to develop in that direction?
Yeah, but I have to mention that the render thread is always single-threaded, so there's no movement there. So what we did is make the control thread thread safe. And I'm wondering if that is very interesting. It means that you can ship your oscillator node handle to one thread and your audio context somewhere else, but it's all control side, UI side stuff. So there's not a lot of performance gain there because the control thread hiccup doesn't matter too much.
Yeah, I just had a question about web UI libraries written in Rust. So I know that there's kind of a vibrant ecosystem to sort of try to bring all web development in Rust, so composed to WASM. And then with these small bindings, have you found that there's a compounding effect? Like say that you're doing your web audio Rust, then in for a penny, in for a pound. So why not do the UI and the graphics and kind of, is there a compounding effect, or is it just sort of the opposite, that it's like adds headache on top of headache?
Yeah, I think we're going really in circles at that point, because you can build, of course, your UI in Rust, but to bring in my library to emit audio inside the web browser, that's just layers on layers, because then you'd use my library to render into a worklet processor to do the actual browser outputs. So I think we're going in the wrong direction there. I'm more inclined to invite you to use my library, and then maybe the port of the web, how is it called, the video card API that allows really raw visual stuff. It's also being ported from the web to Rust, and you can build like an optimized browser without a browser that is doing visual and audio stuff. So I'm more looking into that direction.
Okay, thank you. Thank you very much. Yes. So we will have to go to the next presentation, which is a remote one. The next presentation is from Xiong Ren. He works at the Shanghai Conservatory of Music in China. He is a PhD student directed by Michel Buffat and myself. And there are other people involved in this project. They belong to the INRIA team in Lyon, Stéphane Letz, Yann Norlaret, Dominique Faubert, and Romain Michon. So the title is about modernized toolchain to create JS patcher object on web audio module from forced code.
Hello, Laurent. I hope you can hear my voice. Yes.
Yes, okay.
So, my name is Rich Hong. So I will present a paper on modernized chains to create these spectral objects and the web audio modules on postcode. And this is a joint research with Graham's research team. So Stéphane Dess, Yann Olahay, Dominique Robert, and Romain Michon, by PhD supervisors. So on what team?
Thank you very much, Xiong. Are there some questions?
I'm sorry, I was just stretching myself.
Thank you very much, Young. I think this is great. Having something like a patch in the web, and very thank you for sharing it to us. And I just wonder, besides all you have done about the audio schema and API coming from FOSS to WASM, how do you deal with messages around your objects you compile for into you and load into your patcher? I mean, are all the controllers and how do the controller are implemented in your objects so that in your patcher we can share some nodes, control, etc.
Yeah, very good question. And actually, it would be too long if I present.
Xiong, maybe you could show the first IDE and the default generated interface for an effect or an instrument, and so that people can understand that what they see in the IDE can be just generated using a line command and reused in any web application.
Yeah.
Share your screen.
Yeah, I will share my screen. So yeah, here in the ID, you can see a algorithm for distortion effect. And this part of the code will generate an example, this interface with one parameter. And I will open the code.
So actually, maybe you could show a more complex UI like the free verb or anything.
Yeah. This is the interface of Reverb and post-ID. And you can have the same thing in the sketcher, which is to open.
So from the first IDE, you can generate GUIs automatically, test the plugin using a live input or a MIDI keyboard or sound samples. And then you can create some code that you can reuse in any web audio application. And Xiong, just by using the generated URL, can also integrate them into his patcher. So you don't have to take some time for building your own GUI if you want to rely on this default GUI.
So here is the builder loaded frame single URL. And this is the container of the plugin interface. I'll try to activate the song. Back in my computer, which is running for some.
I think he doesn't. Il a pas partagé le son. I think you didn't share the sound. Okay.
Okay, thank you, Xiong. I'm not sure we have time for another question. We are 10 minutes late. Thank you very much. So it's time for Gérard Roma. Gérard Roma is working at the School of Computer Science at Leeds Trinity University in United Kingdom. His project is about using WebAssembly code instead of JavaScript, and his presentation title is Comparing Approaches for New Audio Worklets.
Yes, all right. Okay, so yeah, this is about comparing approaches for new audio worklets. So the question I was asking myself is it worth using WebAssembly for new audio worklets? So we know that we can create audio worklets to create custom audio notes using JavaScript or WebAssembly, and we've seen WebAssembly being used to port existing libraries. But what about new audio worklets? Is it worth using WebAssembly? And this bears like a kind of more latent question about at which level. So of course, we can see the Web Audio API as a kind of implementation of the classic paradigm, the music end paradigm, where we see a music program as a graph of unit generators. And so in Web Audio API, these unit generators would be the audio nodes. And we usually think in terms of oscillators and filters, but we can see there's a kind of an implicit abstraction in that we can encapsulate this into a synthesizer, as we just saw in the previous presentation. We can create more complex algorithms and encapsulate those as unit generators, and then create a graph of synthesizers and effects and so on. So there's a question about at which level do we want to work when we create audio nodes, audio worklets, and specifically using WebAssembly. So WebAssembly, of course, is the idea of this kind of bytecode format that allows you to compile different languages and run them on the web. But what's kind of cool is that you can run it in many other places now. So even a microcontroller, for example. So it's kind of an exploding field, WebAssembly, and it's quite interesting. So it's kind of becoming the new Java virtual machine of sorts. And perhaps the potentially most popular languages would be using C++, and of course Faust. But here I'm looking at kind of basic languages like C++ or more popular recent addition is AssemblyScript, which is a TypeScript that can compile or compiles to WebAssembly. So how to use WebAssembly for audio worklets is actually audio worklets themselves are not trivial as compared to script processor nodes. So you have to do a lot of things like registering, loading, dealing with parameters and so on. And WebAssembly is also not trivial. So how to connect both things is not immediately obvious. So there's documentation for each thing in the respective documentations. But for connecting both things, I use these tutorials from both the Chrome team and the Firefox Paula Denot at Web Audio Conference. And so these were very helpful for also because the implementations are slightly different. So understanding how to use WebAssembly in audio worklets. So that's how I started this project. Then, of course, in terms of related work, we've seen lots of libraries ported to through WebAssembly to the web, like Faust, Csound, Maximilian, or Essentia. Most of these can be seen as music N languages or music N-like systems. That again, my question is about what if I want to create a new audio worklet from scratch? So here I compared mainly 3 different languages: JavaScript, C++, and AssemblyScript, and at 2 levels of granularity. One would be in terms of WebAssembly, one would be to call WebAssembly 1 call per sample. So if you want to do sample accurate processing at the JavaScript level and then optimize parts of that. Or perhaps the more like normal approach would be to take the buffer. So in audio worklets, you're handed a 128 samples buffer. You can handle this directly to WebAssembly and do all processing in WebAssembly. And so this would be the pure JavaScript approach. Here, what I did was to implement an algorithm that you don't have in the Web Audio API. So this is a sawtooth band-limited sawtooth oscillator using the polyblep algorithm. And so, of course, this is the simplest approach. You are already using JavaScript, so you don't have to do so much, only deal with the audio worklet. And the code, as you can see, can be quite short. I mean, it's a high-level language, but still, of course, when you do signal processing, you still tend to use kind of C-like syntax and typed arrays and so on. So it's perhaps not so different from doing C++ actually. And it has the problem of a garbage collection, which makes it less predictable. So you can have an unpredictable cost at any point if you're not careful. Then this would be the C++ approach. Here the question was, how do we use this C++ code in JavaScript? So normally in the music N paradigm, we're used to kind of see an object-oriented mapping of the unit generators to objects. So it would be nice if we can just use C++ objects in JavaScript. So what you can do for this is use mbind, is this feature that allows you to interface with C++ in an object-oriented way, but it has the issue that it generates a lot of glue code. So it's basically you generate a WebAssembly file, but also lots of JavaScript that wraps this WebAssembly. And then how to load all this code is a bit different between Firefox and Chrome. So it becomes a bit complicated. And then, so the one in the top is the sample-based example. And then for using the buffer-based example, you need to start thinking about memory. You need to think about how to share memory between JavaScript and WebAssembly. So a common practice is to call the malloc function from the JavaScript side and then wrap the memory in a typed array and then handle this pointer that you get from malloc to the WebAssembly side. Then the last version is the AssemblyScript. In a way, you can see it as best of both worlds. So you have like a TypeScript syntax, very similar to JavaScript, and you've got a WASM output. What I found really interesting is that the language, the tooling, the documentation, everything is targeted to WASM, so it makes it very easy to understand what you're doing and what you can do with the bytecode with a WASM format. And we've seen, it's a new language, we've seen already quite impressive demos like JavaScript Music by Peter Salomonsen, which I think will be presented at this conference as well. And then AssemblyScript doesn't allow you to map the objects directly as we saw with mbind, but it does have JavaScript-like modules. So you can basically create your module and export functions, and you do everything you would do in JavaScript and then use it from JavaScript as you would use a JavaScript module. So it's quite convenient. And then for the memory, there's also a way to offset the start of the code in the WASM binary. So you have like a bit of a chunk of memory that you can work to share it with JavaScript. So I did a bit of a performance comparison. Excuse me. So here I implemented 3 algorithms. The SO oscillator is the one I've been showing with the examples. Then was inspired by a comment in one post by Paula Denat about the sine oscillator being implemented as using the sine function in Firefox. So this looked like a kind of low-hanging fruit for doing something that you can compare to native. So that's sawtooth is something that would be an example of something you want to do that is not available in the Web Audio API in terms of like the low-level audio nodes. Whereas the sine oscillator would be something we can compare to a native version, and also added a backward low-pass filter also based on the Firefox code that we can also compare to the native code. So I implemented these 3 languages, and then the per sample and buffer based, and then I ran a test that was thought from a user point of view. So instead of looking at the load or the time it takes to compute a function, the question is how many audio worklets can I create in an application before the thing starts to glitch consistently. So we can have some spurious glitches as well. That was a bit complicated, but to make it a bit objective, the test was to stop when it's really, really distorted all the time. And so these are the results. The bottom is the sawtooth oscillator, so it's the one that doesn't have a native version. So if you want to compare to the top, you need to scale the graph a bit. And at the top, we can compare native and JavaScript and all the others. So there were kind of striking differences between platforms. Particularly for JavaScript versus native, I found like Chrome tends to favor the native implementations, whereas in Firefox, it seems that, by the way, Firefox is the blue and Chrome is the orange, of course. So in Firefox, it was quite surprising that the JavaScript is quite fast and can actually reach almost native or something similar to the native implementations. I have to say this is done with Firefox 99 and Chrome 100. Current versions may change completely. I think the current version of the filter is much faster in Firefox, but also in Chrome, this doesn't work anymore because now I think there's a limitation of the number of WebAssembly memory instances that you can instantiate to something like 100. So none of this works anymore. The test, but of course you can still use all the implementations. Then another interesting fact is that still the WebAssembly, it's not so easy to make it faster than JavaScript. Actually, it's still complicated. Clearly, the thing is that using the per sample approach is a lot slower, so that this shows that there's a significant cost in making a call from JavaScript to WebAssembly and back. So this means that the story is quite clear. So to take advantage of WebAssembly, what you need is something really expensive running on the WebAssembly side and minimize the communication. So back to the original background question, this kind of biases the API a bit towards making more complex things. For example, whole synthesizers inside the audio worklet, as opposed to doing like basic things like oscillators and filters. And then the assembly script performance is a bit mixed. It's a bit hard to make it perform at the level of both C++ or JavaScript. I guess this may change in the future. So in terms of comparing, sorry, I'm a bit unaware of time. I don't know how I'm doing. Okay. I still have 20 minutes? No. That would be so. I've done 20 minutes already. Okay. Well, so I'll make it short then. So in terms of WASM versus JavaScript, so from the experiment, so the idea was to look at it from both how easy of use and the performance. So from the point of view of the ease of use, well, WASM is quite hard to use with audio worklets. You've got to load the WASM code in the audio thread along with the audio worklet code. You have to deal with how to manage the memory. You have to add an extra tool chain, an extra language. You have to think about how to interface the code inside the WebAssembly. And in terms of performance, there's a clear penalty in the communication. You can have improvements. I think this experiment hasn't really shown the improvements, but I think they're quite likely. And of course, there's some advantages, such as not having garbage collection and the possibility of using other languages, which I think is perhaps the most promising aspect of WebAssembly. There are also quite a few limitations of this study. So I only tested very simple algorithms. So again, it would be interesting to test more expensive algorithms, not necessarily complex, but at least more expensive algorithms. And this was only run in one machine. I didn't test on mobile. So it might be that the differences between platforms and between implementations are quite diverse. So it might be that this kind of eases a bit the difference in performance between WebAssembly and JavaScript. So yeah, for future work, apart from more expensive algorithms, one thing that would be really interesting is to look at the WebAssembly code itself, because there's a text format you can try to interpret. So we could see what's going on from the WASM generated by the different approaches and see why they perform better or worse. And of course, we could do this with all the different languages that you can use for WebAssembly. So, in conclusion, the question was, for new audio worklets, would we use JavaScript or WASM? The answer is always complicated, of course. In terms of ease of use, well, it does increase the complexity, so you need some reason to actually use WASM, for example, because you want to use a different language or something. From this point of view of the ease of use, I found that AssemblyScript strikes a quite nice balance. It's quite easy to use, and hopefully the performance will improve in the future. And in terms of performance, as we've seen, it depends on what you're doing. So it might not be worth it for really cheap stuff or things that run quickly, but it might be worth it if you run more expensive algorithms. So that would be a sort of conclusion. Still, I think WASM is very promising for other reasons, like being able to run your code anywhere, being able to write other languages. But still, for audio worklets, I think it's a bit mixed. So that's it, and I'm happy to take any questions.
So thank you very much. Other question in the audience? Yes.
Oh, hello. So I was wondering about the speed differences. So is everything compiling down to WebAssembly? So JavaScript is just faster?
Sorry, can you repeat the question?
Oh, so for all these different languages, are they all compiling down to WebAssembly? And if so, for JavaScript being faster, is that just an easier compilation process, or?
Well, JavaScript here didn't compile to WebAssembly. JavaScript is JavaScript.
Okay, so everything else is compiling to WebAssembly and then being run.
Yes.
Oh, okay. Interesting. All right.
Hello, thank you for the talk. I'm still wondering why you should evaluate WebAssembly in this scenario, because you have no performance gain. It's more complex. I'm super skeptical on the fact that you will find performance gain because of the nature of WebAssembly keeping, the communication costs with the JavaScript world. So JavaScript is compiled in a way by the VM. So it was interesting to evaluate WebAssembly. I've done WebAssembly benchmark on other scenarios. Sometimes it's great, most of the time it's not. It's great to reuse code, like I've been working with Adobe to take C++ code to make it WebAssembly. But why do you say at the end use WebAssembly for complex and JavaScript for simple audio worklet? What do you mean by complex? Like, do you think it's easier to take existing code base doing audio processing in C++ and then compile that to WebAssembly? Or is it because of the nature of JavaScript making it more complex to write?
Well, I have to say it is a potential take home because actually I haven't really proven anything for complex code. That you're right. So far, in only some cases there was some of the C++ code that could be faster than JavaScript code. It is an expectation that if you have something really expensive, it could actually be faster. I'm not really sure. You seem to be skeptical. But it's a claim that you see around. The other thing is, of course, the garbage collection. This is something that, for complex code, is sort of an advantage to be sure that you're not being garbage collected anywhere. So that would be an advantage as well for complex code.
Yeah. Anyway, you're right. You need to do some testing and evaluate it. Garbage collector could be great because you're doing real-time processing, and you should avoid garbage collector at all costs to have, like, cuts in the UI thread. Oh yes, interesting. So thanks for the evaluation. We'll see if you manage to find a scenario where WebAssembly will be better. Thanks.
More of a comment than a question, but I'd be curious what the performance trade-offs are for non-audio data. Like, for example, if you're doing very rich, dense FFTs and then moving the FFT data down through a chain and then bringing it back into the audio domain, for example. So it lives its life as non-audio data, as kind of frequency spectrum data for a while, and then manipulations are done on that. I don't know if that was part of your benchmark suite or if you stayed purely in the audio domain, but I'd be curious to see if that's kind of one of those zones where WASM might give the boost that you're looking for.
Yeah, so I think in alignment with what he said, there's some existing, like, I found like a blog post doing something very similar to this and comparing WebAssembly to JavaScript for non-audio stuff. And it was a similar result. The WASM was not very fast, but that was like back in, I won't dare to say, but it was many years ago actually. So I think that the WebAssembly is improving in performance, and you can see some people. I don't know. I can't tell you exactly where, but there's some places where it's being used for accelerating. I've seen, I think, for example, from the machine learning community, I've seen places where the clear advantages of WebAssembly. For as you said, for offline. For online, there's a chance that you don't have so much time actually to leave it work for enough. So that's kind of the question again.
A last question.
I'd be quick. It's a bit related to what David said. So for me, it's easier now, much easier, to write DSP programming that becomes in the end an audio worklet using domain-specific languages. Because when you need sample accuracy using the Web Audio API, you don't have any choice but making audio worklets. And programming complex DSP, well, complex, not so complex, but as soon as you have to deal with sample accuracy, the code can become quickly cumbersome in JavaScript. So something that I'm using FOST, but in one line of FOST, you can create something that you will take maybe hundreds of lines of JavaScript in an audio worklet. So in that sense, for me, it's easier to write directly at the audio worklet level. And what is interesting with the Web Audio API is that for some parts of the processing, it's easier to reuse Web Audio nodes like analyzers for FFTs and so on. And for example, with the guitar tube amplifier simulators that we wrote, we really exploit the dynamic behavior of wave shapers that we cannot find exactly as easy to use, or they do not exist in FOST or in the other languages. So for me, taking the best of both worlds is really the best way to develop web applications with Web Audio. Okay, that was just a conclusion, not a question.
Yeah,
Thank you.
so I would agree. So basically, yeah, all this project is a bit of an interest of looking at WASM because of it's a really, really interesting for this reason, for being able to use so many different languages. So that's the real interest, I think. But of course, you would also want it to be fast, and at least as fast as JavaScript. So
Thank you very much. So the next presentation is a remote one from Charlie Roberts. He's working at Worcester Polytechnic Institute in Massachusetts. He's writing DSP algorithm directly in WebAssembly. And the title of his presentation is Dynamic Single Sample Audio Graphs with WebAssembly.
Hi, everybody. Can you hear me okay?
Yes, thank you.
So I'm mostly going to be talking today about a library called Janish.js. It's a JavaScript port of the Gen extension to Maximus P jitter. And it's a graph-based system for single sample processing, low-level nodes, do things like read and write from buffers, single sample feedback. And I use this in a couple of other libraries that are built on top of it. And in particular, I wanted to point out one of them, which is this library for Jibber and doing live coding, because having dynamic graphs that are constantly in flux is a big part of what this research is, and it might differentiate it from some of the other conversations that we've been having so far in this session. So currently, the way Janish works, or in the original version, is define an audio graph using the JavaScript API. Janish then compiles that graph into a flattened JavaScript function. So you have one JavaScript function that represents the entire graph. At runtime, the JIT compiler optimizes this, and then the JIT optimized function is used to generate audio in an audio workload processor. And so this has a couple of advantages. The end function can be pretty fast. And so, yeah, in 2017 paper I presented at WAC, I had results that were on par in certain situations with the native nodes. In other situations, the native nodes blew it away. But in some cases, it can be really, really fast. And being able to support single sample feedback is really important for DSP and sample accurate scheduling as well. So those are some of the things that Janish had going for it that were great. Disadvantage is the graph is static. So I'm compiling everything into a single JavaScript function. And that means if I want to change the graph, I have to recompile that function, and then the JIT has to re-optimize the function. And in particular, the JIT optimization is something that can lead to audio dropouts if you're using a low buffer size for your audio callbacks. The other problem that's already been mentioned by Gerard and others is this garbage collection when you're using JS. Janish has a single static memory heap that it uses for all of its DSP memory, but there's still only so much you can do to avoid garbage collection, which is something else that can potentially cause audio dropouts. So for these two reasons, wanting to be able to have more dynamic graphs and also wanting to avoid garbage collection, I wanted to move Janish to WebAssembly. So with WebAssembly, you get ahead of time compilation, which means you don't have to wait for the JIT to optimize at all. This might not be an issue if you're only loading your JavaScript function once and it's then running for the duration of your time on the browser page and you're never having to modify it or optimize it again. But if you're having an audio graph that's constantly changing, then it becomes a problem for JIT optimization. And then also to get rid of the garbage collection. Notice I did not put computational efficiency in this list. And so that was kind of an open question when I started this, and we'll talk a little bit more about that in a second. So how? The way I did this is a little bit different from what's been talked about so far. I decided to port Genish directly to WebAssembly or the WebAssembly text format. So Gerard mentioned that there's this text format that can be freely converted back and forth to the binary Gaussian representation. And it's not that scary when you look at it. This is the actual WAC file for Genish. This is a function to, maybe that one's a little hard to explain, but this is a function to round up a number. It loads it out of memory after looking up the memory location, and then it just calls this function on it to go ahead and round it up. And for me, I thought it was interesting to actually learn WebAssembly at that low level, just out of curiosity, and potentially I had an idea that maybe there were additional optimizations that I could do if I really understood the language at a lower level. So those are some of the motivations for kind of writing it directly in WebAssembly, as opposed to using a compiler from Rust or C++ or assembly script or these other languages. But of course, I'm giving up all the amazing abstractions that these languages provide to make it easier to code. So I'm not trying to diminish the trade-offs here. But those are some of the justifications I had for choosing to go with WebAssembly text. So this version 2 of Genish kind of works like this. You still define your audio graph using a JS API. The JS API then creates a memory layout and a shared array buffer, which is shared with the Plasma kernel. That runs bytecode using that allocated shared memory. And then the audio workload processor node uses samples generated by the WASM kernel. So one big difference is that this version that I'm talking about right now. So you can easily just go and change a location in memory to completely alter the function that's processing a particular chunk of memory and enable all sorts of different types of shenanigans. So I'm going to do a couple of demos right now, just looking at some of the, to just kind of illustrate the differences between the original JavaScript version of Genish and this new version in terms of performance and what some of the problems were that I stumbled upon. So this is the original Genish playground, and it's had a whole bunch of tutorials and different examples of ESP algorithms if people are interested in checking it out. But I'm just going to jump down to the bottom of this introductory one and look at the raw oscillator tutorial. I'm going to change the number of oscillators to 150 here and go ahead and run this. I don't know if you can hear that annoying buzzing sound or not. It's not super important if you can't, but hopefully you can see in the bottom corner the render capacity, which is about hovering around between 5.5% and 6% for 150 sine oscillators, which is pretty great. And you can see here that there is this one big, long JavaScript function that has been compiled. So this is the flattened audio graph reduced to a single function. The JIT optimizer can handle that, and you get this great performance out of it, or I think it's pretty good performance. But just refresh this to make sure it runs again. If I take the same code and let's do 350 oscillators. So down at the bottom here, hopefully you can see it, and bring it up just to make sure it's in the video feed. It's at 99% and it's not moving. So this is basically a point where the function that I've compiled is just so large, so many lines of code, so many expressions inside of it, that the JIT optimizer can't do anything with it. So even though you would think this 350 oscillators, well, it's a little more than double 150, so we should have 12 to 15% that would be our render capacity. It actually just doesn't even work because the JIT optimizer just kind of gives up, and you can't run this function fast enough to get real-time audio happening inside of there. So I have this other dynamic WASM version, and there's a lot of technical details about how I implemented the dynamic WASM version in the paper that I'm not going to get into here. But there's also a playground that's linked in the paper where a lot of the same examples and tutorials are present, but using this dynamic WASM version. So I'm going to do kind of the same thing. I'm going to go down here, and we can start with 150.
Thank you. Does anyone has a question?
Hi, thanks for the talk. I was wondering, how often do you regenerate the graph in Jibber when every time you evaluate, or more often? And you mostly talked about the performance of the graph itself, but I wonder how the performance of the graph generation is and how fast it is, because it's also interesting for me for live coding.
Yeah, so in Jibber, there's actually like two levels of, at least two levels of code generation that happen. But for the DSP side of things, two levels of code generation that happen. So you have like these lower level genish functions that are used to create instruments. And then there's like a higher level graph that gibberish handles to link all those different things, those genish functions together and route to buses and whatnot. So it happens whenever you instantiate a new instrument or add a new effect. Those are basically the times when the code generation takes place. It's mainly during instantiation of instruments, which can happen quite a lot during a live coding.
Okay, so but if you do nothing to the code, then nothing will be generated.
If you do nothing to the code, yeah, it'll only be generated once. And
Okay.
Just run.
Thanks. Yeah. Okay.
Jan had a question online.
Yes.
He asked about the 4 times improved performance with the compiled version and why that is so different. And yeah, I think it's all due to graph overhead. I really do think that's what it is. And I did do some tests just trying to figure out if it was the function call, the dynamic function pointer resolving that was causing it. It really did seem to be the case.
Thank you.
Hello, thank you for your talk. And I was wondering why you go for the one sample based approach. What are the advantages over the buffer?
There's just, I guess primarily, there's lots of DSP algorithms that you just have to have the single sample approach. And so FM, for example, you know, the canonical FM algorithms on the original Yamaha instruments, they all had a single sample feedback loop inside of it, you know, things that you can't do with the built-in web audio nodes. And so I definitely wanted those types of things to be available in the library.
Thank you.
Thank you. We have a last conference now. No?
Normally, Charlie is giving a performance this afternoon, so I guess you will have his tool demonstrated. Not sure. I'm not Charlie, but I guess so.
Okay, we have a last presentation for this morning with David Polik. Is David Polik here? Thank you. So David Polik is coming from Lelila in France. Yeah. And okay. And he has written a web application for exploring microtonal harmony with web audio on web MIDI.
And full screen. Yes, we have a tonality diamond. This presentation is about microtonality, and what microtonality is kind of a blanket term for anything that doesn't fit into 12-tone equal temperament. And I'm sure most of you know 12-tone equal temperament is the system used for pianos. It's been around for a couple of hundred years in sort of standard use. And the idea is to put intervals slightly out of tune so you can use several of them in one place. It's kind of like having a really blurry picture. And microtonal systems are about looking for more specific ways of hearing intervals. And I think it's of interest to web audio developers because it's an area where there's more and more interest in microtonality with MPE. Ableton have just put a microtuner in live, but the tools aren't really there yet. And so I think web audio could sort of get there first. And there's a lot of different systems. There's different equal divisions of the octave: 17, 19, 31, 41, 53, 72. And there's a lot of historical temperaments where the intervals are uneven, and so if you play in a different key, you get different senses. What I'm going to talk about here is just intonation and the harmonic series. And for that, I've built this little app. Please forgive my aggressively minimalist approach to CSS. It's almost punk CSS, but not quite. But the main thing I wanted to do with this is make it so you can sort of hear the tones, because this is the tonality diamond is a diagram for teaching theory and for showing how the harmonic series interacts with its inversion, which some people call the subharmonic series. Some people say the subharmonic series doesn't really exist. So, but we're not going to get into that now. I'll just quickly give some basic vocabulary. Cent is basically a measurement for figuring out how. Sorry, this thing's falling down. How far a tone is from the equal temperament, from an equal temperament semitone. And it's really good for communicating with musicians who are used to that system, which is most of them in Europe and America at least. And but I think one wants to think of intervals as having their own identities rather than thinking of them as a blurring of an equal temperament tone, because it's actually the opposite which takes place. And I've put up the little formula for converting ratios to cent. Octave reduction is bringing a ratio between the 1-1 and the 2-1, or between 1 and 2. So the third harmonic 3-1 gets brought into the octave by bringing up the denominator by a power of 2, and that will be a 3-1, a 3-2, a 3-4, 3-8 will all be heard as the same pitch, but in a different octave, as will the reciprocal. And in just intonation theory, you talk about limits, which all ratios within an octave using prime numbers or odd numbers. Yeah, and I just put this here. It shows how easy it is to work with frequency ratios in code. You simply take your base frequency and you multiply it by your ratio. It's really much nicer than working with MIDI pitch bend numbers or cent detuners in traditional DAWs. And I'll just go here to the diamonds. And this is the 5-limit diamond, and it's kind of the basis of Western tonality, major and minor chords. And the system that we use is equal temperament is kind of based on slightly out of tune stacked 5-limit ratios. And then as you go up to the 7-limit, you get the natural 7th harmonic, and you get these dominant 7th chords and minor 7th chords. And then as you go up to the 9-limit, the 11-limit diamond, this is what Harry Partch used for his 43-tone scale. This diamond presents 29 tones, and with the 43-tone scale, he filled in certain gaps with harmonies of these tones. Partch was the main person to use the tonality diamond, and to make it part of music, he built a marimba based on it, which was partially the inspiration for this project. But it had been presented by Max Meyer in the US, and another version by Augusto Navarro in Mexico in the 20s, so about 10 years before Partch. And I believe he was aware of those. So here you get the 11-limit. And I'll just show quickly the if you don't do octave reduction, then this kind of shows the way the harmonic series fits into this. Whoops. So you go harmonics and subharmonics. When they're octave reduced, you get the chordal system with the diamonds. Adding ratios of 13. Ooh, let's go back down to 196. And I've decided to do this because I saw one of these Novation launch pads, and I saw a 15-limit tonality diamond. It's kind of, shaped like that. And so I thought, hold on, this should be an instrument, really. So let's hope this works. You've got a lot more musical resources there than you do in a 12-tone system. There's also I think the big future in intonation is higher harmonics. Lamont Young is a composer who's worked with a lot of higher harmonics with sine tones, and I think he's gone as far as the 2304th. But also there's extended just intonations. The composer Ben Johnston has worked with 176 different intervals in a string quartet. Johnny Reinhardt, who runs the American Festival of Microtonal Music, uses a scale called 128, which is based on the 8th octave of the harmonic series. And there's also a theory called primodality, which is creating modes out of subsets of higher harmonics that Zeana Eroz uses. So there's people beginning to work with this, and I've adapted the diamond to higher primes here. So there's kind of all these other intervals out there that we can experiment with. It's kind of new to me. The other thing I'm doing with this project is kind of turning it into an arpeggiator and a looper, which is not yet available to the basic to the general public, but I hope to make it available soon. But you get this kind of and I'll be doing some performance with that tomorrow, I think, with some of these different ideas. And yeah, I think there's a lot of possibilities there for developing kind of mini DAWs that can use these kind of systems. I've experimented with trying to get this to output MIDI pitch bend numbers to a traditional DAW to Logic, and it works about half the time, which isn't really good enough yet. But I'm sure there's talented people that can kind of put that thing together, because there's so many different microtonal systems that kind of deserve their own tools, and DAWs are kind of clunky. They're always based on, you always get the little piano keyboard and the piano roll thing, and they don't adjust. They're not fluid. And so web audio really seems like the right thing. And it's I think also with MPE and everything, microtonality will make a huge sort of jump in popularity in the next 10 years. So I think it's worth considering for people who are developing applications. I'll just quickly mention, if I can figure out how to scroll on this thing. Microtonal University is actually a laid-back Zoom group put together by Johnny Reinhardt. But there's a lot of people who've been working for years with microtonality who come and present and teach and everything. So I've put up the links there. And it's just about to enter its second year in September. And there's also going to be live concerts with the American Festival of Microtonal Music again. So that's good. But these are worth checking out. This is a fantastic resource for people who want to learn more about microtonality. And also essential reading, I think, is Genesis of a Music by Harry Parch. Basically brings the whole idea of musical ratios into musical practice. And I think turning theory into practice is also a good thing for the web audios, to take diagrams and things and turn them into performance tools at the same time as being music education. Also, The Arithmetic of Listening by Kyle Gann recently came out, and it's also an excellent resource. Thank you.
Thank you very much. I have a small question.
Yeah.
Have you planned that we can connect your application to web audio modules?
That would be a nice idea. I think I mean, I haven't actually started working on that, but yeah, it would be good to develop that. I think.
I have seen on your application like there are some parameters to control sound synthesis.
Oh yeah. It's incredibly rudimentary at the moment. I mean, it's just basically ADSR for oscillated bank, or there's a kind of where are the sine terms? Let me go. There are also, you can kind of set the thing up with the sines for drones, which is nice because you can really hear things kind of beat together. But yeah, no, it'd be great to set it up with other synths and things like that. It's at the moment just a very basic idea. So,
thank you. Another question? Yes.
Thanks, very interesting. You showed an example with prime numbers. Was it?
Higher primes. So I'm jumping over, sorry, I didn't explain that well. I jumped over the first 15 odd harmonics and went straight to 17 and then took the prime numbers above that. And it was just to create a little subset from the higher harmonic series to get a little feel for that. I haven't quite developed it into...
There's no theory behind it, no deeper meaning.
Yeah, no, there is certainly, as you get into higher harmonics, things work together really well, especially if you avoid the lower harmonics. This is Johnny Reinhardt's theory. If you avoid the lower harmonics, which kind of drag you toward tonality, there's room for a kind of, it's not really dissonance because things work nicely, but it's a kind of strange world. Of course, here with the idea with the tonality diamond, there's the kind of one running through the middle of the thing. So you can see how things work together. It's like showing how chords can be built and modulations can happen within a just framework. But I think there's a huge, that will be the future of music, is kind of going further into the harmonics, definitely. And the subharmonics, I should say. I think there's an interplay between the two of them. So
interesting, thank you.
Any other questions? Thank you.
Thank you very much. It's time for lunch now. We have only 15 minutes late. We have to be here at 2 p.m. So, comment on dit bon appétit en anglais? Okay.
Enjoy your lunch.
Having to see the microphone. I'm a percussionist, and I've played with Diamond Marimba. I'm a great fan of Harry Park. And I also invented something called the Marimba Lumen with Don Bubla, which is a MIDI controller. And one of the first projects I had was a woman in Colorado who was into intonation systems, and she hired me to come out and program the classical xylophone interface with her different scales. So I know what you're saying. Making the instrument is hard.
I just kind of saw this, and it's like, okay, that's
for me, having the real. So if you could build something with real, and watch people exhibit physique, this is wonderful, but it's digital. And actually, as a composer and a synthesizer person, I think it better sounds.
Oh, definitely.
But to have an instrument, it just draws more people in when you also have the physicality with them. But I love the theory. It's a really great way to go. Not very much, because I'm a percussionist and the instruments. So only very recently I got into digital instruments, but I work in the electronic field, so I've worked with players in that way. It's not my favorite thing, but I'm a great fan of Harrison.
Okay, yeah.
I've played with Lou Harrison.
Okay.
I sat right next to Lou. Have you read his primer, his Lou Harrison's music primer? Oh, it's a lot. He's always doing calligraphy, and this is John Cage. He says, "Such as I am, rather chance a choice than choose a chance." Lou Harrison, but yeah,
It's great. I mean, his stuff is so. It's so beautifully cinematic.
His Jala music, yeah.
On Macdonald University, John Schneider, who plays, did a lot of blues stuff.
Yeah. I played a lot of his percussion music, and it's actually the other stuff.
Gamelan.
Yes, I've done. Yeah, I actually was on played that instrument. Fun stuff. I love the beating stuff. The sine waves, that works really well.
The other stuff, I'm not that good at
It took me a while the coloring, but then I saw the color. It was the octave shifts. And I'm also just fascinating with tuning systems. I don't know if you played the glass harmonica and watched different people with their wine glasses have like diamond patterns and stuff that they use for their artificial scales. And what jumped out at me was, you know about the double bridge dulcimers? If you play dulcimers, you should look at.
Yeah,
you should look at because they have double bridges. So
you can move them around.
but it's just the way you work the scales. I mean, they're not really for microtonals, but the scales are not like a keyboard, you know. So it gives you this other way of traversing, and like you say, you know. You might look at some of the dulcimer tuning systems because it's quasi-diamond. It won't give you a complete thing, but of course, the beginners going for the large scales is maybe too much. But if you can explore that space with this other geometrical way of looking at it, which is I did that once to try to learn the dulcimer. It was very hard. I took 2 glockenspiels, I took them apart, and I put them on a table. So you've got a ladder here, and a ladder here, and a ladder here, and things repeat or don't repeat. So it's a lot like the diagram, and it's a little bit similar to the diamond. It does stretch like a diamond, so it might actually be more from one into the other, which you might look at something like that.
I mean, this was kind of this is convenient thing, so I wanted to try it
Just
out.
look at hammer dulcimers. Look at find a dulcimer player, or the the santur. Many different cultures have different instruments, but they all have this strange. As a drummer, you know, I'm interested in different kinds of layouts. Steel drums. Have you ever seen the way steel drums are laid out? They're not diatonic. They're not chromatic. They have concentric circles, and the different pitches are laid out differently.
That's a really cool idea. It's kind of
And you're seeing this now in the Han drums, where people are playing these fancy like oiled drums that you play with your hands. They're also using these tuning systems. In the steel drums in Trinidad, they have complementary whole tone scales where you got one here and one here, so you're limited in the harmonies you can make. All these constraints combined with tuning systems. Makes me.
I think it's What's your name?
Mark Goldstein. I'll give you a card. Where are you located?
I'm located just outside of Paris, actually.
Oh wow, I'm in San Francisco now.
Okay. I went to high school in El Dorado County. That was kind of a ways away, but. Okay.
It's very good to hear some sound. And,
yes. I said the same thing.
Because this morning, it was a bit sloppy. My other computer.
You should have him play in the lobby while we're waiting.
So I hope that you'll be there for the jam session.
Yeah, I've already spoken last night.
With I am sorry, this morning it was both about instruments and performance. Like WebAssembly was much computer science.
Well, actually, that's interesting. I mean, I'm kind of getting. I was interested in the where he was using 150 oscillators and that kind of stuff because that's
why you're associated with a different.
That's something.
And also, we finally should work together because I am a member of the group that created web audio plugins.
Okay.
So instead of having just your oscillators, you can just plug in 3 line words, a real synthesizer, a real analog reproduction of very complex instruments with lots of settings, effects, and so on. And you'll be able to experiment much more.
That would be cool.
And better than that, you can propose a menu, a list of instruments so people can switch and so on.
Yeah.
So and
I mean, this is like just a super basic thing.
I'm not sure that I will have time to do this during the conference because I'm a bit on a wild ride as the general chair. Yeah, but later on we can just exchange emails. And maybe after the holidays, it's not. We can try to.
I'd love to get like.
If it's open source, we can look at it.
I was going to GitHub the code before but it's at the moment my code is a little sloppy.
This afternoon, come to the demo session.
Okay.
You know, my students are playing guitars and showing plugins.
Okay.
But if we have 5 minutes together, I can show you some synthesizers that we got.
Yeah, because I've seen some of that stuff. Analog again, because it's really it's excellent stuff.
Okay. So this would be a very good addition to you.
Okay. Yeah. Thank you. Sorry for the technical.
No, it's
you made up for it. You presented does a wonderful talk.
Good.
You know, we all thought, oh, this music theory stuff now coming, and the guy doesn't bring together his technology, what this will be, and it was great. Thank you very much. It was really, I think everybody appreciated it.
I bought this Chromebook thing about 2 days ago because my other computer started falling apart.
Because what you did is you moved us on the level of music. One.
First,
and second, you gave us an additional
cultural
argument why we're doing this.
Exactly.
Because we are close to coding and we're close to mathematics.
But those are talk were really computers free stuff.
Web audio could be so much faster than like a big company to get
in the
like
90s or late 80s, maybe now in the 90s, I programmed my DX7, doing microtonality, and that was a pain in the ass.
I mean, but this you can kind of get into very quickly. So No, I had an old DX7 and I loaded in Scala files.
Right? Was that? Do you remember how that worked? Did we have detune to detune in Cent? No, all the.
I'm assuming it
So
must
if
be,
you
but I can't remember.
so if you wanted to have the octave somewhere in the middle, you went kind of minus 700 something or something. No, it was like that. I guess.
I think so.
It was a pain in the ass. This I would definitely remember.
Yeah, and it's still the same thing though with MIDI pitch bend. You have to, it's like it's pure hell. But I think still kind of interfacing with other tools would be good for web audio. Spitting out MIDI files. I don't know if there's anybody who's doing good web audio to MIDI plugin.
Là, il y avait le responsable du
Well, I don't.
That way you can write something on your mobile phone and you can send it to the producer or something.
Parce que là, ça a été labellisé pour 1 an. Donc, tu dois finaliser un dossier pour la fin de l'année.
I think this space, which is close to you, perform with it. It's very pedagogical. You can. I think the great thing, anyway, in any case, and also for microtonality, which I didn't think of for a long time, is the space where it's very pedagogic, it's very operative, and it's very manual. So this is what web audio brings for all kinds of stuff.
But I mean, that's why it's so great, the web audio.
And if you want others to experience what you have just coded, you just send the link.
Yeah.
You don't go, oh, you must install this.
So you're going to go join us for lunch?
Yeah, I'm just going to pack up this kit. Oh, thank you for your help.
On t'entend. Tu nous entends? Il est là. Tu m'entends? Non, il n'entend pas.
J'entends rien.
Ça, c'est bizarre.
Ah, mais on a coupé le Zoom, non? Ou tu l'as relancé?
Ah oui, pardon. Alors, tu m'entends maintenant?
Oui.
Bah non, attends. Stop it. Oh my God. Parce que là, du son, ça sort là.
Le son, il sort ici.
Ouais.
Je paye 10 000 cher, on a besoin de quoi? On arrête.
Donc ça devrait pas faire les sons.
Non, c'est peut-être pas moi dont tu parlais.
Ton son, il sort ici. Ok.
Viens avec moi, tu fais la Ah ouais, parce que vous avez remonté, je crois, les tables avec des sacs à l'étage à la salle.
Le problème, c'est
Et là, moi, normalement, là, on devrait sur le...
Pour mener.
Bah là, j'ai enlevé le son.
Ah, voilà, là, on a le son.
Non, si.
Est-ce que s'il parle, on a le son?
Tu peux parler? Il m'entend pas.
J'entends pas.
Continue à
Faut que je
parler.
parle?
Oui.
Je parle, test, 1, 2, 1, 2.
Ça marche.
Je parle, 1, 2, 1, 2.
C'est bon. Sauf que du coup, je ne peux pas allumer ici. Enfin, je peux pas allumer le zoom ici.
Mais en fait, c'est parce que...
Parce que le son est ici encore.
Comme ça, il me le faut ici parce que c'est le son qui va...
Oui, mais il ne devrait pas sortir ici. Il devrait sortir là.
Et pourquoi il sort là?
Exact, on ne devrait pas l'entendre.
Ah, et dans Zoom, là, tu peux sélectionner le truc.
Ah, c'est ça. Attends. Ok. Est-ce que tu m'entends? C'est un code.
Attends, alors. Donc là, tu as sélectionné le...
Complete audio 1.
Donc là, c'est sûr que je sors.
Ah, il y en a d'autres. Il y a un identico-système au haut-parleur complete audio 1. Ah, c'est la même chose. Bizarre.
Là, je sors sur la table. Et pourquoi je le récupère? Après, je le récupère 2 fois. Je l'envoie ici. Ici, il récupère. C'est ici que je récupère. Là, je ne l'envoie pas normalement. Un truc, je comprends pas. Pourquoi? Donc là, j'envoie le son. Je le renvoie ici. Il va là.
Ça fait un écho quand même.
Vas-y, remets le son.
Ça marche?
Pas encore.
Là, on est où, là?
Vous êtes prêts ou pas? Ça va? Bientôt.
Test. Non, c'est bon, il n'y a pas d'écho. Parce que tu as enlevé le son? Test. Allô?
Et là, s'il parle, par contre, il y a un écho.
Tu peux parler? On n'entend pas.
Après, c'est ça? Non, après. Ouais, je suis derrière. T'as besoin de trucs spéciaux pour commenter?
Une souris, puis mon adaptateur.
Ah, tu as ta souris? Tu as ta souris?
Non, j'ai pas ma souris.
Alors,
Ouais, elle parle, on n'entend pas.
USB ou USB-C?
1, 2, 1, 2.
Ouais,
Je parle.
Et moi, quand je parle? Ah non.
Oui.
Du coup, le son, je le sors en HDMI ou je le sors en...
Non, avec le mini jack, on peut tester le son déjà.
Ça, non. Là, c'est coupé, ouais.
Ça marche. Bon, ok.
Personne avant qu'on c'était quelle image ici?
Hein?
Avant qu'on le son ne marchait pas, c'était quelle image? Comment est-ce qu'on entendait la personne?
Qu'est-ce qu'on attend? Attends, je n'ai pas compris la question.
Parce que là, le matin.
Ouais.
Là, le son ne marchait pas. On voyait son écran et on l'entendait.
Oui.
On l'entendait par où?
C'est par là que tu entendais, c'est ça?
Non, 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 on entendait là.
Ah, bah alors je le repose passer sur le.
C'est pas ça.
Là, je peux sortir le son. Là, je peux sortir le son.
Ça, tu veux dire, aussi, je suis
Ok, ok, thanks.
J'allume le micro, j'attends. On peut y aller. C'est Michel.
Les gens arrivent, là, ils sont tous en train d'arriver.
Vous avez des galères, non? Vous avez des galères techniques? Ah ouais. Donc là, c'est live sur YouTube aussi, et ensuite les gens pourront voir l'enregistrement ou pas? Ouais.
Tu peux faire la pub dans les sacs. Ils ont tous des autocollants du W3C. Ça, c'est le logo XR VR.
Ah, justement, ma chérie me demandait. Justement, ma chérie me demandait ce que c'était.
D'accord, si tu peux, je te les pose.
Ouais, ouais.
Tu les montres. Vous avez tout ça dans vos sacs. Ça, c'est WebXR. Il y a WebArtist.
Je vais montrer ça aujourd'hui.
Hello, hello. Okay. So everyone's here, nearly. Okay, so we'll start. It's my pleasure to introduce you David Rousset from Microsoft, who is doing the second keynote. And David, well, he will present himself, I think, but he came to talk about web audio and web extended reality, virtual reality, and fun applications. So, David.
Thank you. So it's my pleasure to come. I've seen some very interesting talk this morning, highly technical. We are just after the lunch. I know that some of you would love to maybe have a little bit of a nap after lunch. So my goal is to keep you awakened with fun demos. It would be probably less technical, but maybe more immersive. Just a reminder, you have that in your bag, like stickers you can put like myself on my laptop. So today we're going to see two of them. This one, if you don't know it, is the logo of WebXR, of XR on the web. This one is WebRTC. I will do a little bit of WebRTC in some of my demos, without, obviously, web audio. So my name is David. I've been working for Microsoft for a long time, like 22 years. So I've been through IE6 up to the death of IE, and then Chromium Edge. I've been co-writing Babylon.js, which is an open source 3D engine doing WebGL, WebGL2, and today WebGPU. And one of my most major contribution to the project, I've been creating that with another David, another French guy named David Catu, was around audio and VR. So I'm a huge VR fan. That's why most of the time when I'm doing conferences, I'm boring about VR. You will see some VR demonstration. I'm working in the developer division, so my official job is not to do that. This is my spare time, so this is stuff I've been doing on my spare time. I guess a lot of developers are like that. We're coding our free time. And my girlfriend is on the first row, so she's a little bit distressed sometimes to see like, oh, I've got free time, I'm going to code today. And the developer division is in charge of GitHub, VS Code, Visual Studio. We've got some AI services like GitHub Copilot. I don't know if you heard about this AI to help you code for you in a way, to help you being more productive. There's some AI, we talk about that with Michel. So I'm doing a podcast with friends also, and we talk about AI also to generate images, like maybe you've heard about DALL-E, GPT-3, and also to generate music thanks to AI. So this is still stuff I have in my mind to try to play with those AIs to do stuff in the web. And you can reach me on Twitter. So DAVROUS is my alias, like my blog, my Twitter handle, and my email address. So for people that don't know Babylon.js, because my demos will be based on my little baby, it's a 3D engine built on top of WebGL, WebGPU. I've already shared that. We also have included support for Web Audio and WebXR. It's an Apache 2 license, so you can do whatever you like with the project, fork it, break it. You can use it without giving us credit, which is what most of the people are doing in the open source community. So thank you. So this was my first open source project, and I discovered the beauty of open source. You know, nobody is reading the source code. People are blaming you not to be fast enough, even if it's a free project and well, whatever. I've managed to convince my old friend to quickly switch to TypeScript. So it's fully written in TypeScript, so we have support for types, and it helps us to be more productive. And we have support for WebVR out of the box. So it used to be a pet project. We started together like a garage project, and it was then used a little bit by Adobe, and then Microsoft started to use it without knowing it was made by a Microsoft employee. So for a specific reason, we do not want to be associated to, as Microsoft employee, to Babylon.js, because just, rewind in the time. It was a time where IE was the most hated browser ever by the web community. So it used to be the most loved one, IE6, yes. And then IE6 became the most hated one. So we weren't really invited to any conferences. So Mozilla was, the best company to work with for open source and web standards. That's why we didn't want to have our name like Microsoft name associated to Babylon.js. But then the project started to be popular and being used by Microsoft. So Bing is using it today. SharePoint, it was one of my last contributions. I don't know if you know about SharePoint. It's a relatively boring product, with documents. And one day they told me like, oh, David, you're currently writing VR support. We love to use it. SharePoint? What happened to SharePoint? Like, I remember about a boring product, and now you would like to do VR. So they're using it, and the feature is named SharePoint Spaces. Microsoft Teams is using xCloud, which is our gaming cloud service, is using for the touch controller on iPhone and Android. So we are just a layer on top of the video stream by the server. And Adobe is using it, is the US Army and other companies. So there is a dedicated team at Microsoft working on it now. But I'm not part of this team, even if I created it at the beginning. So web audio and Babylon.js. So when I started to, so I'm a huge passionate about audio. I'm doing a little bit of music composition myself on my spare time when I'm not coding or playing video game. And when I started to play with web audio, it was, you all know about web audio, I guess. But for people that would like to use Babylon.js, the spirit of it was it's supposed to be simple for that any kind of developer should be able to write some 3D in an easy way. So it shouldn't be too complex, and 3D developer, we love to make stuff complex just, to print out we are better than the other average developers. So we have specific vocabulary like shaders. So, when you talk about shaders to people, like, oh, wow, this guy must be really awesome because you know about shaders. So, but it's fake, like, you know, it's just like a facade to pretend we are great. So we wanted to simplify a lot of the concepts so people don't have to bother about what is a vertex, you know, stuff like that. Obviously, up to a certain level, then you need to understand a little bit what's going on in 3D. And I wanted to have the same spirit for web audio. I didn't want that to be too complex, so I wanted to simplify a lot. And what I had in mind also was to support the scenario of video game and later on VR. So we have support for ambient sound, which means that it's not specialized at all. It's going to be played, if it's a stereo file, it would be played in stereo or mono. It could be, you know, omnidirectional or directional, meaning that you can, thanks to web audio, have just a cone of sound being available in 3D. And then the way to have the attenuation done in 3D is by default, it's linear, meaning that if you know, you can have a sound being specified that after 100 meters, there's no real unit in 3D, but let's say after 100 units, you won't be able to hear anymore the sound. And it's being handled either by our code or directly in our format. So when you save a scene, you know, 3D scene, you can either use the Babylon JS format or GLTF also today, which is a standard format used by the industry, to put the reference to sound there. So meaning that you can build a scene, and we're going to see a demonstration of that, just using the 3D modelers, put the various sound, and have a full immersive experience with 3D audio. So now I've got a full lot of experiments. So the first part is non-VR, and the second part is VR, which could break at any time. So let's start by very simple stuff. Let's hope I've got sound. Let's check that you can hear my sound. And I've got a mouse. Will be better than that. Great. So you see that the way to create a sound in Babylon JS is super simple. Babylon is our namespace. Sound is the object. You give it a name. You point to the URL, and you specify in which scene you would like to add this new sound object. And then it will manage, you know, the download in sync way of the sound. It will create the audio context if it's not being created yet. It will check, you know, now you need to have a user interaction to enable the audio context. We're doing everything like that for the user. Because for a lot of users, they don't really care about web audio. They just want to play sound. And this is what was the intent. So once this is done, so you have potentially a callback to just tell you that this is done. You can use async await now to, you know, to have like the magical, the beauty of async await to hide the complexity of callbacks. And then you can play the sound. So get ready. This is just a gunshot. And this was the first demonstration. So this is super simple, something that a lot of people would like to do in games. Michel told me that his student has been building a first-person shooter. How surprising, like people would like to build this kind of game. So they will be able to do that in their game. So the next one, this is something that I haven't coded myself. So the beauty of open source project, when it works, people start to contribute to your project. You have to wait like almost 100 years before it happens. But it happened. And then someone wanted to have sprites being supported, meaning that, you know, you're going, rather than having 6 files being downloaded in parallel, you're going to download a unique file. So for performance reason, it could be better, you know, to download a unique file. And the same concept of sprites in 2D, meaning that, you know, have various images that are going to cycle and animate. You're going to be able to access to specific parts of the file to be able to play it. So there is a unique file there, you can see, named 6 sounds, meaning that there is 6 sounds included into this file. And then you're going to define the various parts. So going to start at 0 for 5 seconds. Then after 5 seconds, 5.1 seconds, there is another part that's going to last 6.6 seconds, etc. So if I'm playing random sound, it's going to play one of them, which is, I cannot, you know, anticipate with sound. So I'm going to play it a second time. So we can now imagine kind of a Resident Evil game, I guess, being based on that. And And you see, it's very easy to use once again. So really, it's simplicity, like the goal we have with Babylon.js. So thanks to the contribution, it fulfilled our dreams. Now we're going to switch, like obviously you're in a 3D scene, so you need to have 3D sounds. So the first part to do 3D sounds is to create sounds, the same way we've seen it before, there. So I'm creating, a sound object, and this is some music I've been composing that's going to be playing in loop during all the talk. So you're going to hate my music after this talk normally. So I'm going to ask to play that in loop. To add spatial sound, I'm going to tune, the audio graph of web audio to enable 3D panning. So this is the way I'm doing it. And what is the max distance where the sound is going to be propagated? And to be able, and then I'm going to set the position in the virtual world. So you see, it's a little bit complex for now. This is the low-level access to 3D sounds. To help people to understand what's going on, so I'm going to unmute the sound. I've displayed those purple sphere, which means that this is where the sound is supposed to live. So if I'm moving into those spheres, I'm supposed to hear the sound. So I start to hear the sound because I'm at the beginning of the circle in a way. If I'm going closer to the center, it should be louder. And now I can move out of the sphere. It stops. And voila. so we are inside the 3D sound. So it's an easy way for people to understand what's going on. And this is done for you, meaning that you have nothing to know about 3D, the complexity of updating whatever is being done for you. Obviously, what you would love to do next is to, rather than thinking about putting a sound object in 3D coordinates, is to create a sound, like we've seen before, create a sound. And this time I'm going to attach this sound object I've been created, the music. I'm using the attach mesh function to a 3D object, which is a box. By simply doing that, the 3D engine is then going to take the 3D position of the object, play the sound there, and update it in our render loop. So now if I'm unmuting the tab, I don't know if you can hear stereo sound there. Maybe you can, I don't know. No, I don't think you can. Well, so just trust me. Like, based on where the box is, you will hear like on the left, on the right, in the middle. If you're using a headset, we have support for HRTF, which means that you will be able to have the feeling it's behind you. So using one line of code, which was the intent. So I'm doing choices for the developer, and up to now, they seem to be happy, which means that if you like to do more custom stuff, you need to build your own web audio audio graph. This one is fun too. So this one, I've created a sound, but with some directional con objects. So I don't know if you know that, but in web audio, you can specify that the sound is going only to be projected into this specific cone. So it means that until I enter the cone, hitbox, I'm now in front of the cone. The sound is being played. I'm, away from the cone. It's not being played anymore, even if I'm close to the object. So pretty fun. So now you can argue, so okay, like it's ugly boxes and simple object. What can we do with that? So the next step is to create like more immersive scenes, like this one. So I'm going to unmute it. And you start to have the spirit of the talk. So it's a bit frightening. So this time I'm moving into the 3D scene. And while I'm moving, you will start to hear some specific sound because it's using what I've shown you before. Like there is 3D objects everywhere in the scene. So just by moving inside the scene, like you will start to hear some objects. Thanks to web audio. Web audio is doing most of the work. What I'm doing is just like updating my 3D scenes to match, to synchronize the sound with the 3D scene. So you have interaction part. And there is other fun part I will show you in VR, if I'm lucky enough. Otherwise, I will switch back to non-VR. just checking the time to see if I'm still on time. Yes, I'm still on time. So to show you how it works, also we have. I'm going to let it like that. So we have an inspector that is useful to inspect the 3D scene. So you can see the nodes there. So you have like, so it's being built by French people. So you see that because it's alley, like arbre rouge. So like, and sometimes American people say, what is alley? How to say that? So alley. So my English accent is not great, but I'm glad that the American people struggled also to pronounce our French words. So it's for just to annoy my American colleagues that we decided to name the object in French. And you have sounds over there, which could be useful just to do some special tests, like for instance, grenouille, which is frogs, for frogs legs people. I can pause the sound. I can pause also the hibou. And normally I should have a music loop. I'm going to pause it. Now you just hear like the flies and stuff like that. So we have included also like all the sound are in the scene graph, which means that you can debug them in an easy way to check what's going on. So far, so good. So the next part is going to, so I'm going to progressively add feature I've been working on to do demonstration. So obviously, you know, who don't know about the web audio analyzer? One people, two. Okay. So in web audio, you have access to a real-time analyzer, meaning it's going to analyze the audio stream and give you the frequencies and stuff like that. And you know, we like that. I'm a huge fan of audio amplifier also, or Dolby Atmos stuff. I like to see visual stuff associated to my sound. You know, like if you remember about Winamp, we have those beautiful visualization. I could like it's hypnotic for me. I could stay forever in front of those stuff. So, and that's why I guess the web audio guys decided to implement the analyzer. This is my own thought about that. So I'm using the web audio analyzer, which is then going to give you access to the frequencies. And what I'm showing you there is if I'm playing the sound. Rather than playing that in 2D, I'm playing that on a ribbon in 3D because everything is better in 3D, to be honest. So I will share the source code of each sample. You can play that on whatever machine. We're running on Mac, Linux, iPhone, Android. So everything is working on all devices. And it's really classical access to the frequency data and play with it based on what you like to do. So to go a little bit further than that, I've got this one that I've been creating like for fun too. And maybe before playing it too much, like my goal with there was to have access to the, in electronic music. So I don't know what's the scientific name of because I'm not an audio expert. Like I love audio, but I'm not an audio expert. So I've been working on my algorithm to analyze the and try to make it visual. So I'm going to stop because I can watch that for hours and then you're going to be bored. But it's being generated by this code. So it's just procedural way to generate, a 3D object. I'm looping through colors of my torus. And based on the frequency, I'm going to display like the torus, like which are far away from my little sphere, are the highest frequencies. So and it's fun to watch, like to just see like it's living in a way. Your code starts to live and do stuff you wouldn't have anticipated. So I really love to do that with audio and 3D. It's it's art in a way, to my point of view. And I was doing that when I was young on Atari and Amiga. So who is Atari in the room? Oh no, which means with Amiga? Oh, maybe we're going to win for Atari for once. Okay. So a final feature before switching to my last sample in 2D. This one is, I've got demos at the end if we have enough time about other demos, but I wasn't sure about the timing. But this one could sound stupid. I'm going to show you why, and you're going to try to understand what's going on. So what's going on? Exactly, the closer I am to the object, the louder it is. The further it's loudest, which is counterintuitive, okay? But why not first? So I decided to let people to create their own attenuation function. So I think in web audio at the beginning, we had access to that because it's also a spec that has been evolved. But I wanted to be able to modify the attenuation function myself with some code. That's why I've been creating this function. And maybe only for me. You know, this is the beauty of creating your own framework. If you like to create something for you, nobody can prevent you from doing so. It has helped me to create this demonstration. So this demonstration is once again using my music, so sorry for that. So we have boxes. On each boxes we have a sound, and when I'm going to move this box to the center of the sphere in a way, like the ring, it's going to boost the volume. So when I'm close to the border of the circle, it should be low, and when I will be in the center, it will be high. And I wanted to do a kind of a mixer, you see what I mean, to mix my music in real time. So it supports multi-touches, but my VR machine doesn't have a touch screen. So you will be able to test. It can work on my iPhone, for instance. You can use many fingers, or on a tablet will be better. So let's do it one by one. And when I'm using it, it's going to use the analyzer also to play it, you know, with fire around. Because particles, well, particle is fun. And then now I can choose the volume based on what I like to do. So for instance, this one is voices, I guess. Oh, no, it's not. It's just violin, but I guess what is... so this is not this one. So this is this one. I know. I remember that there is some voices. They are not there anymore, okay. And what you can do also is to associate box together. So let's imagine that I would like to do the French version of that. So I'm going to attach this box to this one and this one. Now I've got three sounds being attached, being synchronized. So if I'm moving the French boxes, it's going to play together. So it was a stupid project. And thanks to that, we've won an hackathon for when Microsoft decided to move away from IE to Spartan, which was the first edge. They have support for web audio, and they didn't know what to do with that, so they've done a hackathon. And on our side, we have proposed that, and because the other projects were really bad, we've managed to win the contest, and it was put online. So sometimes hackathon is just about because the other people are not good enough. Okay, so maybe you're waiting for failures. Now let's switch to VR. Obviously, we're still going to do some audio stuff in VR. So this is my grandmother and this is my brother. So WebXR. So first we need to give a little bit of explanation about what is WebXR. So maybe you've heard about WebVR. So WebVR was before. It was only for virtual reality. There was WebVR 1, WebVR 1.1, and we decided to support WebVR 1.1. And then everybody decided to, let's deprecate WebVR and create WebXR because, you know, nobody cares. We care because we are creating engine for people. And this is also the beauty of using an engine. Like developer using Babylon, they don't care about the fact that everything changed. Our role is to reconnect everything as far as we can. So WebXR is an evolution of WebVR. So it started first to be in VR. So on Oculus Quest, or you have a headset on a desktop on PC, but it can also do augmented reality scenarios, either using, phone like this one that's called LiDAR. So the iPhone is not supporting yet WebXR, but you're not forced to have a LiDAR. It can use RGB cameras to do a deep learning analyzing of the 3D around you and create a kind of 3D mesh to let you put your object there. The browser supporting it are Edge, which is Chrome in a way, Opera, which is Chrome in a way, Chrome Android, which is Chrome, and Samsung Internet, which is based on Chromium. So unfortunately, Firefox used to support WebVR, and we all know that Mozilla is currently struggling. They don't have the same head count as Google regarding the browser. So as far as I know, WebXR is still not supported by Firefox. Regarding hardware, you need to have a SteamVR compatible headset, which could be an Oculus, HTC Vive, Valve Index. We have headset also at Microsoft if you're interested in that. The Oculus Quest can do that in a standalone mode also, meaning that the Oculus browser will support WebXR. And you need to have not an iPhone, but a recent Android smartphone for augmented reality. You can also use the HoloLens 2, which is a very cheap device available everywhere for only $5,000. So feel free to use it, but it supports also WebXR. If you like to play with it, we have doc.babylonjs.com with WebXR stuff. So I'm going to show you how to transform the scene we've seen together just before in VR. So if you remember right, there weren't a lot of code. I forgot to show you the code at the beginning. If you believe in a specific God, you can start to pray for this God. So at the beginning, we had this line of code that was only loading the scene. So I'm going to close the sound for now. And inside this scene, everything was defined. The sound, position, the interaction with the scene. So it was created in 3D Studio Max by a 3D artist. And he gave us the file. We are loading that in Babylon, and everything is ready. So it's one line of code to have the 2D experience. And we are forcing ourselves with David to have great features in one line of code when possible. It's kind of a challenge we're giving to ourselves, which sometimes is complex. And this is the way to create the WebXR experiment by default. So once the scene has been created, you're going to use the await keyword, because now we have a modern JavaScript. You're going to call this long function, create default XR experience async. And then by default, if you're doing that, it will check which is your currently connecting headset. Is it an Oculus Quest, an HTC Vive, whatever? It's going to download from our CDN the model of the controllers for you, so you don't have to worry about that. And if you give to the function also a specific object, which is the floor, because we don't know what is the floor in your scene. You can have decided that could be a specific object. If you give us the name of this object, so once again, just for fun and to check that American people are supporting the French characters, we name it Allée, which is the path to the castle in a way. So once you have that, if you have WebVR supported, you will have this icon being displayed. Okay? So now the next step is to switch into VR. That's why I'm trying to speak, before switching to. So this is the feedback you should be able to see if it works. So just remember, just 2 lines of code. Okay. And now if it doesn't work, it's because of Oculus, okay? Oh. No, wait. You never know. So it seems to work, but I forgot to enable the sound. Oh, I'm going to try to do something if I'm lucky enough. So normally you can see everything I'm doing. So this is the beauty of VR. Okay. So let's switch back in VR. Oh, I'm super lucky today. Ah, you don't see it, obviously. Okay, so let's switch back to... So I'm doing my live there. Okay, can see the feedback. Yeah. So now you see that the controller has been downloaded. When I'm moving my head, it's moving the camera, which is pretty convenient. And by default, you have a teleport target there, you see. And I can also decide where I would like to be teleported, like in front of that, for instance. As we are mapped to pointer events, it's going to work using touch, mouse, and also laser controllers. So we are generating pointer events for laser, which means that even if this scene has been created before VR, it's working in VR. You see? So now let's visit a little bit this scene. So there should be some specific sound there. Yes, some new sound. It's going to be more obvious over there. So you can discover the scene. And you hear some piano. Can you hear that? So it means that I can click there, and there is a skeleton playing piano there. So thanks to web audio, I can discover some part of the scene. And for fun, we have clickable stuff. So we have Hamlet. We have Clippy. Do you know who is Clippy? Who is old enough to? So Clippy is dead. Too bad. So I'm a huge fan of Quantum too. So I never really understood if the Schrödinger cat is dead or not. It's dead. Definitely dead. I don't know if I'm facing. No, I'm not facing the right part of there. Okay, I can move the NI6 NIE. So look over there. You see, nothing is there yet. Nothing clicking on the tomb of I6. There is a logo like the background on. So this was the first stupid demonstration in VR. So using just spatial sound. So you see that, do you agree that everything is better in 3D and everything is better in 3D in VR? So now the next step, as I love to do music, so I started to work on this project this time. And the initial goal that I shifted, because it was obviously on my spare time, I wanted to do a kind of, I don't know the name in English, the name in French, maybe you're going to help me, it's Simon, le jeu Simon. You know, where you need to remember like the colors and the sounds. And I wanted to do like a memory game in a way and on a virtual piano. So it was the initial goal. And then while I was coding, I've done something else, obviously. So what I ended up doing was to play sound on a virtual piano. And do you remember the ribbon, you know, that was doing real-time analysis? So I'm using it there. And it's a 360, so it means that you're switching, you know, the note there. And it's beautiful for me. Like, I'm pretty proud of the colors, which is super rare as a developer to choose the right color. So for once, it was great. So it's pretty simple. I'm loading the various sounds. I'm, you know, putting it there. And when I've got support for a touch or a click, it's going to play the sound. So to play that in VR, like this is a 2D view of it, you need to switch the camera. So I like to be at the center of the circle. So for that, I'm going to switch camera to remove this one and use this one instead. So you see now I'm at the center of it, which is not obvious when you're not in VR. And now I'm going to, well, praise the God, I'm going to try it immediately. Tell me if it's not, if you cannot use the output. Oh, this is not good sign. No. Can you use the output or not? Okay. And now? Cool. So this is around me. So this is made to be run in only the Oculus Quest 2, which is wireless. So I'm using the cable to be sure that I don't have Wi-Fi connection on stage. But it's cool because now I have without the wire, I can turn around forever. With the cable, you will have some accidents, so don't do that at home. And now I can play the sound. You see what I'm trying to do? I was thinking about a music for a movie. I don't know what you think about that. It could be a great movie, music for movies. So again, I'm just, you see, clicking on stuff to enable it. The next step, what would be great is to, I need to check what's around me. It would be to tap on it. So I haven't done it yet, but the next demo will use it. Using, checking if an object is touching another object to enable the NOT. So just to show you that this is also working using the HoloLens. So I've got a video. I didn't bring my HoloLens. So this is the same one. So it's using the HoloLens with these holograms. To make it better on HoloLens, you need to remove the background. If you put a black texture, it's going to be transparent. That's why I can see through. And then I'm going to switch in VR by clicking this button. So now I'm not in VR. I've got a 2D hologram. Now the piano will be around me using the HoloLens. And you see we have hand tracking in Babylon.js also. So you can use your hand, and the Oculus Quest is doing that too. And now I can click and play the wrong note. You see, that's why I put some colors to help me to remember on which note I should click on. So it will a little bit my memory game. Okay, so you're still alive. Yeah. So this is a tricky part of my session. So I'm looking at the average age in the room. Who knows about Jean-Michel Jarre? I'm pretty proud of you because most of the time going to conferences, people are like, who? And I'm so sad. So Jean-Michel Jarre, for people that don't know him, is a famous electronic music composer, could be considered one of the fathers of electronic music. He's French. And he has created this great experiment on stage. It's a laser harp. You have laser, he's got specific gauntlets, and you can cut the laser to play, some specific sound. And I was completely amazed by that when I was young. And one day I thought but let's do that in VR. It's obvious I need to create that in VR. So I've been creating that in VR. Then I wanted to do more. I want to use you. I want you to be part of the experiment. So you need to go on this URL using your phone, your PC, or whatever that can generate sound. I don't have Wi-Fi on mine, so maybe it won't work. But so aka.ms/JMJ, Jean-Michel Jarre. Okay. So you have some sound. So normally, if you're connected, you should press the unmute button. Cool. We are going to test that it's working fine. Don't be surprised. I'm going to play sound on all your device. Ready? Okay. So you're going to be the speaker. because this is not the right name. This is not my music. Okay, so now I need to switch in VR. And normally, this is what should happen. I will cut the laser and I will play the note on your smartphones or device using WebSocket and Web Audio. Okay? Crossing fingers. So I will probably start to struggle to display what's in the headset. So for now, you cannot see what's going on, I guess, like usual. Here it is. Can you see it? Great. Ready? Well, it works. And you see, I can see you. Thanks to WebRTC, I've got a feedback camera to control that you're not doing bad stuff with me. So what we use there, WebRTC, WebSocket, Web Audio, WebXR. Okay, don't tell me the web is not powerful enough to do stupid stuff. So thank you for helping me to do this demo. So there is more serious demos. So this is my more or less real job at Microsoft, not completely. I'm working on SDK to connect people using the Microsoft Teams infrastructure. So using a JavaScript SDK. It's using WebRTC under the hood to do video and voice calling, SMS, or to join a Teams meeting. So I know we are using Zoom, but Microsoft Teams is a competitor of Zoom or Slack, if you know it. And I wanted to do a buzzword, a metaverse demo. Okay. So as we don't have enough time, I've done a video because it requires someone to connect to my Teams meeting, and it could, could be complex. So my girlfriend, once again, she's my biggest fan, is on the first row, and I'm using her also to do my my demonstration because I've been stuck at home for more than 2 years. I'm so happy to see you, by the way, real human in a real room. It's awesome. It's the best metaverse ever. But for 2 years, I was at home, and unfortunately, Christina was the only human being at home, so I'm forcing her to participate to my demos. So what we're going to see, I'm going to show you the prototype running inside Babylon.js without the connection to Teams in a way. So this is a 3D scenes once again that can be in VR. And this is a museum. And the idea was to have a virtual visit of a museum, of a house. And I'm going to press the call button. The call button is going to call Christina, who will be in Microsoft Teams. So we will see Christina there instead of this fake video. And also, I wanted to be able to visit the virtual home to put like the video feed on my end, so I can walk around the house and discuss with the sales representative. So let's suppose she's a sales representative. So this is exactly the same one, but using this time WebRTC and Web Audio coming from Microsoft Teams. And let's do that in a video. It lasts 2 minutes, a little bit more than 2 minutes. So hello, I am in this virtual museum inside a metaverse running on top of WebXR and Babylon.js. And let's imagine I like to visit this museum with a lot of paintings. But I could be quickly lost because I'm not really an expert in art. So I've included an option, which is really cool, being able to call someone over Teams. So what I'm going to do, I'm using Azure Communication Services to be able to call someone inside Microsoft Teams. So it's a regular Microsoft Teams, nothing special about this version. And I'm going to press the call button, and I'm going to establish a connection with this beautiful woman. So normally, I should be in the lobby in the other side, and she should be able to accept me. And as soon as she's accepted me, so hello, Christina. So Christina is my girlfriend, so she helped me to do this demonstration. And Christina, can you please help me to go inside this museum because I'm a little bit lost?
Yes, of course. Could you please go in front of you and go closer to the wall that's on the right or on the big room? Do you see it?
Okay, I'm going to take you with me on my controller. It will be easier, so I'm going to take you there. So is it on my right?
Oh, yes. Look at the picture on your right, just the first one. It looks so beautiful.
This one?
Yeah.
So what do you think? Should we buy it? Do you like it too?
It depends on the number of the zero after the first
Don't
price.
worry, it's not the price, it's the when it was made. So I don't know about the price. Maybe we should discuss about that later on. So, but it's great. We agreed on this one. So as you can see, so what you see at the top right is what Christina was seeing in Teams. So I was taking the WebGL canvas and I was streaming it as a video feed to Microsoft Teams. So when I was moving in real time, she was able to see that. And it was completely improvised, trust me, like we didn't script it, but it really worked. She was able to tell me like, go that way, what is this object? So we managed to have this kind of collaboration experience. Obviously, going back to web audio and VR, we can use audio to localize, objects. For instance, I could put the sound of Christina, in the center of the room, and if I'm going, far away from it when she will speak me, I know she's speaking on my left. This kind of advanced interaction, and I thought it could be interesting to do kind of virtual visit to buy houses, from VR. So if you'd like to go further, you can try Babylon.js. I hope you will love playing with it. We have Web Audio, WebXR support. We have also a 3D GUI in a way, if you like. Everything in VR needs to be done in the canvas, unfortunately, meaning that you cannot have HTML classical control that will be projected in VR. So you need to rebuild your own GUI library. So we've done that for you. And check my blog, you will have access to most of the sample I've shown today. And thank you, merci. If you got questions, it's the time.
Thank you, David. Any questions?
Nothing broke. No question. Nobody would like to do VR.
Maybe online. I don't know. Check on the... Okay, by the way, all the students on the top right of the room, they wrote games with Babylon.js this year. So if you are curious, other people to know about it, they can show their creations.
Michel told me it was great. So if it's good enough, we'll check that. You can be featured on our babylonjs.com site.
Okay.
So send that to me and I will check that.
So come to show your games to David later.
And in exchange of a little bit of money, well, we'll discuss that later on.
So I'll ask a question. It's not meant to be confrontational at all, but I'll just say that. So I'm a web video game developer with audio, and our engine unfortunately uses 3JS. I know.
I'm so sad.
I know, but so this is actually I've known about Babylon.js, and this looks fantastic. So it's really wonderful work. And in your completely unbiased opinion, can you please kind of to web audio developers that are kind of considering the two, talk about maybe not to pit the two against each other, but just in general, kind of what are the frameworks to consider when somebody's making the choice? Like, what am I going to start off with as a framework?
Based on the fact you are audio, you like to do an audio experiment and need to choose between FreeJS and Babylon.js. Yeah. So the philosophy are different. So and then there is pro and cons because of that. In our cases, we wanted to have everything in the box being maintained by us, mainly in the community, because we've seen FreeJS. So we started after FreeJS. So we decided to do architecture choices different from FreeJS because there's no really interest to do a copycat of it. We wanted to have a different spirit. And we've seen a lot of people complaining about the lack of, of issue being maintained or PR integrated or plugins. There's a lot of plugins but that are not maintained by the core team, I would say. So the beauty of having a lot of plugins mean that you could have like much more advanced or custom stuff being done by the community. The community is still bigger in FreeJS than Babylon.js. But in the other hand, like if you choose Babylon.js, you have the guarantee that we will maintain it for you, avoiding at all costs breaking changes. So we have sometimes breaking changes because like when we're switching from WebVR to WebXR, we cannot have our API being strictly identical. But we're going to have some documentation to help you to migrate from the previous one to the new one. So it's more a general philosophy different. Regarding audio, to be honest, most of the time, FreeJS got better stuff because of the community and you know, the people know more about FreeJS doing audio stuff. And we wanted to do more stuff for gamers on our side. It's super rare that we have games being built on Babylon.js. Today, Babylon.js is used by you know, people doing stuff in the industry to design buildings, to do e-commerce, stuff like that. So audio is not their main priority, unfortunately. So this is the answer. Like if Babylon.js is good enough for you, you will have everything set up in an easy way, as you've seen. But if not, either you use your custom library. You can still use your custom library in Babylon.js, but maybe you will see more you know, documentation or blogs on FreeJS. So I started to be I try to be as unbiased as possible, because normally if you're like pragmatic, you should choose Babylon.js. But
Other question?
They're all dead.
So it was a really wonderful, impressive, and fun demos, David.
I hope so.
Thank you very much. So if you've got no more question, we can continue. And David will be here after at the coffee break, so you will be able to talk with him. And I encourage my students to say hello to David and show what you did. Sure, no more question.
Okay, I've got a lot of stuff to unpack, so
okay, so
thank you so much.
Thanks a lot. Mika, il s'appelle Mika Fitch, il est là? Ah, il est là, d'accord. So, enchaîner. David? What? Ouais. So the next speaker is online, and he's well, not a game developer, but the guy who is making the music for independent games. And he was present on the audio Slack channel, and this is how I met him. And he used different technologies for making the music. It's I think generative music and with some design for an independent game. So the title of the talk is exactly the sound of Wider Place, a web-based puzzle adventure game, and it's by Mika Fitch. So, are we ready to go? Yeah.
I think so. Can you see?
Yeah, we can see your screen. Not yet your video. Did you activate your webcam?
Yeah.
Ah, yeah, perfect. That's good. That's good. Hi, Mika.
Hi, I'm really excited to be here. I got a lot to share, and I'm just gonna.
Thanks, Mika. Maybe do you have a demo of your game?
I could, yeah. Let me just see if it's running right now.
Okay. Ah, il y aura le son. Il y aura le son.
This is like the current version that I'm working on, and I don't know if you'll be able to hear it, which is like the whole point. But
Did you share your screen by checking audio? When you share your screen, you must check share audio. Okay, stop sharing your screen and do it again. Yes.
all right.
Okay, we should have sound now. No? Il n'y a pas de son? No sound? We cannot hear sound. Can you hear sound on your side? Qu'est-ce qu'il fait? Ouf, no, no. Oh. Just. Oh putain. Okay, we lost him, I think.
Can you hear me?
Yeah, you're back. Okay. Okay. So the joys of hybrid conferences.
My sound broke.
Okay, so I'm sorry to have asked this question. It's very nice, these views. Yes?
Okay. Can you hear me?
Yeah, we can hear you.
Okay, sorry. When I shared my screen that way, it crashed.
Ah.
So, but there's if you want to see a demo, you can visit wilderplace.place.
Okay, so we'll share. Okay, can you share again your screen without the sound then and just show the URL? Okay, so I can say a few words because I played with this game and the music is very nice, it's generative, a lot of contextual things happen. And the technological stack he used is very interesting because he used web audio plugins. The DX7 is a web audio module that is a reusable plugin. And he used many different technologies that he presented. And the result is really impressive for an independent game. Okay, so we cannot hear the sound. So, okay.
Yeah, sorry, no sound this time, but you can kind of see how the beginning of the game is.
Oh yes, we can hear a little sound. No?
Oh, can you hear some? It's muted now.
Oh, okay, no.
Yeah,
Okay.
probably no sound, but yeah, you can see it's like a little puzzle game.
Okay, so maybe we have questions anyway in the room because we must go on. So any question about Mika's work? Maybe you saw him in the Slack channel from time to time. Mika, are you here?
Yeah.
What's happening? Okay, so I have a question myself. Okay, because I'm maybe the only one who tried your game. So you said that you are using multiple instances of a DX7. Isn't it a bit overweighted solution for making music in a game, or how does it behave in terms of CPU usage and so on?
it's pretty good. I'm using something like 30 instances, I believe, and each one has like 16 voices. And I had to do some performance optimizations where I would put some voices to sleep if they're not being used. But it actually works really well on the phone, and I found that the WebDX7 is not the main performance bottleneck for the most part. I mean, there's a limit to how many voices you can have. So I definitely have to be mindful of that, but there are other performance things that are more important, especially garbage collection. That seems to be like the biggest thing.
Okay, and finally, you were happy with the DAO format exchange? What's happening?
The DAO format was really, really useful. And I don't know, if it's going to be widely adopted, but for my purposes, it had all the data that I needed right there, and I was using XPath to get the data like whenever I needed it. And it was much simpler than trying to fit everything into standard meeting format.
Okay. So thank you, Mika. I'll share the URL of your game on the website directly in the program because we've got some technical problems for sharing the sound and maybe the pictures too. Okay, thank you very much, Mika, and thanks for having participated. So during the next talk, I'm going to add a link to the game so they can try. So next speaker is Philippe Milo from Audio Kinetics, and he will present how he ported the WISE audio engine used by most AAA games on PC, on game consoles, and so on to the web platform. And it is now included in Unity. So when you target the web platform with Unity, maybe, I don't know if it's shipped yet or he will say not yet, but soon you will have the WISE audio engine that is a reference. So Philippe, I let you set up and give you. Okay. Test. There we go. Okay. Wow, that's loud. Okay, so
Hello, everyone. My name is Philippe Milo. I'm a developer at Audiokinetic. I'm part of the WISE SDK and runtime development team. So today, I'm very happy to show you the progress we've made in supporting web audio in the WISE product. So very quickly, we're going to go through exactly what WISE is for those who don't know. And this is actually a long-running project for us. We've been working on this since even before 2019. But in 2019, we had a pretty big push for development, and this is kind of a follow-up to that. So I'll be explaining that in more detail. Then we'll go through an actual live demo of a game using the product. And then I'll explain exactly why this is so difficult to make it happen. Then we're going to go through the same demo again, but this time with the WISE profiler connected so that you can see under the hood what's happening with the sound engine. And then again, a technical overview of why it was so difficult to make the profiler connection. And finally, I'll close with some feedback about the development experience, because we're not typically a web development company, and this is kind of a first foray for us. So we have an outsider point of view for this. And of course, time for questions at the end. So WISE is an interactive audio solution. We're middleware, and it's very popular in the games industry. And it's a product that has many parts. So there's an authoring tool that is used by a sound designer. So it's a visual tool so that they can design the soundscape of their game without writing lines of code. There's an integrated profiler inside this authoring tool so that you can connect to a game and see in real time what's happening under the hood. Of course, there's a runtime part that's integrated inside the game. So that includes a sound engine, a spatial audio engine, interactive music, and a collection of DSP plugins that like various reverbs, flanger effects, and stuff like that. This runtime is integrated in a game using a C++ cross-platform SDK. And we have ready-made integrations of this SDK for Unity and Unreal Engine. And today, so I'll be able to show you basically all 5 parts, except for the Unreal Engine part, but the Unity part. So why should you care about this? WISE is used in the games industry a lot, also outside of it, but games is the main business. It's used by very small studios. You have very large games like Ratchet & Clank and Assassin's Creed using it, but also smaller indie games like Firewatch or Limbo, Rocket League, stuff like that, using it. And the reason why it's so popular is because of how many platforms it supports. So you can see here, we support every mobile platforms, every desktop platform, and all major gaming platforms, even VR. But as you can see, there's one glaring omission, and it's web. So that's what we're trying to fix here. We want to treat the web platform as just another one of these, because you can actually run games on the web, and it works. So this is, as I said, this is a long-running project. For those who attended the W3C workshop on web games back in 2019, we showed a functional text-based application demo. So it was integrating the sound engine and showing off all the different parts just in a visual, in a text-based menu. And it was using preloaded assets. So that means you had to download the entire game assets up front before you could launch a game. So that was not ideal. But we put this project on ice because there was some uncertainty regarding shared array buffer and security in browsers, and also because the audio worklet node was not fully supported in every browser at the time. So fast forward to 2022, those are no longer problems. So what we want to do now is take this project and make it much farther, take it much farther. So compatibility with Unity, have actual a way to stream assets instead of downloading everything up front, WISE profiler support, and basically treating the web as any of our other platforms with automated builds, packaging, and testing. So I think that's enough talk. I'll launch the game so you can get a feel for it. Okay. Maybe take this down a bit just so that it doesn't explode the speakers. Okay. So this is for those of you might have seen this before, because this is the WISE Adventure game. This is a project we use to basically teach the WISE integration in Unity. So it's used in the certification process for a while. So we took this project and basically exported it to WISE using a build for WebAssembly. So let's start. And as I play, obviously, pay attention to the way the sound and music reacts to the user input. Right now, we're outputting a stereo mix just because it was easier to set up for the room. And so if things are set up properly, you should hear the sound panning around as the camera is moving.
Hello, adventurer. Our village has been struck by a plague of evil. Can you help me save Allegro Kingdom?
I'll skip the dialogue so we can...
I believe I have... I remember placing... Why can I not retrieve it myself?
Looks like the panning isn't quite set up for this room, but it doesn't matter. I'll still be able to show the rest. We'll move forward, and as I cross the bridge, please pay attention to the music. You're going to hear a transition because this is using the interactive music system of WISE. So these transitions can be programmed on actual bars of the music, so it's easy for a musician to program. And when I say program them, I mean programming them in the visual tool, not writing the code, obviously. And as I approach a thread, you'll hear other segments of the music being layered in. And when I eliminate the thread, it comes back. So pretty simple stuff. Let me skip forward to a different segment. Oops, sorry, I forgot something first. Going too fast. So first, I'm going to enable spatial audio so I can show you a part of the game that is designed to showcase spatial audio. And so the reason why this is a special area of the game is that we set up the scene in Unity so that it sends a simplified version of the geometry that you see here to the sound engine, so that the spatial audio system can actually compute the way that the sound of the different emitters bounce around in the walls and ceilings of the scene. So it's not like it's not just a plain reverb DSP effect. It's actually computing the sound waves. So let's see. I'm going to place an emitter right here.
Greetings, adventurer. I heard you'll be venturing into the woodlands.
And as I move around, you'll
best
hear
in these
the
parts.
sound of the
You
emitter
would best be
change as
careful.
it's being occluded by
I was there
geometry and
yesterday to gather
diffracting
wood
around
for my
corners of the
smithy,
geometry.
and the dark plants had already taken root. Luck alone saved me. I may make implements of battle, but I'm no warrior.
Diffraction
As
around
the
this
evil
corner.
sent a ball of venom my way, I turned to flee, and my sword swung on my belt, deflecting the poison.
So that gives you an idea of
and precision,
what WISE
you may
is usually
also
used
be
for.
able to deflect
So I'm
them.
going to close this for now and show you why this was so dang hard to make it run on the web. And a lot of it has to do with Unity. So let's go over threading. For those who saw my talk in 2019, you might remember that that was the main subject, and it's still an issue in 2022, unfortunately. So where is this coming from? Okay. Yeah, exactly. It's a reflection. Yeah. Back in 2019, we had this working. So the sound engine starts and manages multiple threads to do its work. So there's an audio thread doing the audio rendering. There's a separate bank thread to manage the assets generated by the authoring tool. And there's an I/O thread to basically manage the I/O requests from the other threads and pipelining them in an efficient way. And all of this, we made it work back in 2019 on the browser by using an abstraction that's provided by Emscripten. So Emscripten, the SDK that can take C++ code and generate WebAssembly with it, allows you to use the pthreads API that you use commonly in desktop platforms to manage threads, and map those threads onto web workers. So the way it works is Emscripten is going to set things up so that when the application starts, there's a web worker pool that's allocated. And when you start a thread using the pthreads API, one of those web workers from the pool is taken, and it will instantiate the same WebAssembly module that the main thread is using. And although it's instantiating a separate instance of this module, it will reuse the same memory heap from the main thread because it's backed by a shared array buffer. And that's why shared array buffer was such an important part of our solution back then. And once you have this shared heap, then it becomes easy to have thread synchronization using the atomics operations that are available in browsers. So that's the way it worked. It worked fine back then. The problem is that Unity does not support any of this. So we had to go back to the drawing board because when C++ code is compiled using the Unity build system into WebAssembly, it's not compiling down the atomics operation into actual WebAssembly atomic operations. And it's not supporting the pthreads abstraction at all. It's not even generating a build that will be backed by a shared array buffer. It's just a plain array buffer. So we had to take this solution on the left, that's what we have running on most platforms, and turn it into this, basically. So it's a truly single-threaded version of our entire sound engine. Of course, there were some corner cases, like, for example, we had our bank thread sometimes waiting on an audio rendering pass because it wanted to unload some assets, but there were still sounds playing. So those corner cases had to be dealt with. Basically, we're no longer waiting on anything, and the bank thread might actually do an audio rendering pass itself. But yeah, this was not easy to do, but eventually we got to a point where it works as a single thread, and we are sharing the same CPU time as the other as the rest of the game, including the graphics rendering pipeline, which means that if the game actually skips a frame, or if it slows down somewhat, then we do have audio starvation pretty quickly. The audio will drop out. So it's not an ideal solution, but right now through Unity, this is pretty much the only way to go. So I'm going to run through the same demo that we just saw, but this time I'm going to connect the Wise profiler so you can actually have a better idea of the workflow of using Wise. And of course, all of this will still be from the browser. So let's make this smaller. Okay. So on the left, I have the game. On the right, there's the Wise application with the Wise Adventure Game project loaded in. So I'm going to connect the Wise application to the game using the profile. And now what we have now that we have a connection, you can see, if I go back to the designer view, you can see here the meter is actually metering the actual output of the sound engine. So you can see right now we're outputting a stereo mix. And this is what's going into an audio worklet node on the web API side. So I'm going to switch to the main profiling view. So you can see on the left, we have a series of API calls that are being made by the game. But on the right, you have a voice graph. So this voice graph allows you to see what's running, all the sounds that are playing in real time right now. So we have music playing, going into music buses. One of them has a room verb effect on it. Those buses are mixed into a non-world bus. At the same time, we have some ambient woodland sound playing in a loop. This is going into a world bus. Those two buses are then mixed together into a master audio bus, and this is what's coming out to the web audio API. Okay, so as I start the game, you'll see this voice graph update in real time. And of course, this is a real game, so you have a lot of stuff going on at the same time. So this can get unwieldy pretty quickly, especially with short-lived sounds popping in and out. So what I'm going to do is I'm going to filter by a container called music region, so we only look at the music for now. So as I approach the village, you'll be able to hear the music change, another music transition, and you'll actually see it in the voice graph at the same time. So right now it's strings and bass playing. I'll increase the volume again. And now clarinet, violin, flutes, like this. Okay. I'm going to approach the enemy we saw before, so I can show you another detail you might have missed the first time around. Oops, sorry. I forgot to move forward in the quest. Okay. Yes, I'm cheating. Sorry. I'm a cheater. Let me cheat some more and make sure that I don't die accidentally while demoing. Okay, so this plant is throwing a projectile, and there's a Doppler effect on this sound. This is a Doppler effect that's computed in real time by using a high-pass filter and pitch shifting. You can hear it as it zips past the camera. So let's look at this Doppler effect in real time, okay? I'm going to switch to the voice profiler view here to inspect and remove my filter and use the filter for the projectile instead. And now I'm trying to inspect it, but it's a short-lived sound. So when I select it, it goes away very quickly. So what I'm going to do instead is go back in the timeline, which is being recorded, to a time when the projectile was being played. So right here. And now it's no longer showing stuff in real time. It's frozen. And I can select the sound that was playing at that exact moment and actually inspect it and all the properties being affected by it in real time. So you can see, sorry, it's not the right one, this one. So there's a high-pass filter, various changes to the voice volume, and a low-pass filter that's not active right now. And now let's go to the designer view and select this sound so I can show you how it was set up. We can see here Doppler effect is a game parameter. So that's the numerical value that the game is sending and saying just how far or how close the projectile is to the camera. And so on this game parameter, we have bound two RTPCs. So these are real-time parameter controls. One affecting the high-pass filter and one affecting the voice pitch with curves on the values. So what's nice about the profiler is that you can actually change these in real time. So I'm going to solo the sound so that you can hear better. So now we really hear that Doppler sound. And I'm going to exaggerate the curve. So now it's really stupidly exaggerated. And with the other sounds, yeah, it sounds ridiculous. So let's dial it back. That's better. So that's the idea. So that gives you an idea of how you can use the tool to change tweak the soundscape in real time. And it's always better to do that while hearing the entire environment. Okay, so let's switch to the spatial audio demo. And now I'll show you another view of the profiler. Go back to the live mode, so it's no longer frozen in time, and switch to the game object profiler view. Remove my filter and choose the main camera to focus on, and I'm going to follow it. So now we have a 3D view that's updated in real time, and it's showing the geometry as the sound engine sees it. So as I said, it's a simplified geometry that's only used for audio computation. So you can see here the locations of every emitter in the game right now, positioned in 3D space, and as well some portals in 3D. So these are the ones that are taken into account for the computation of reflections. So I'm going to put my emitter down again.
Greetings, adventurer. I heard you'll be venturing into the woodlands.
And
word
lower the
travels
volume.
fast in these parts. You would best
So
be careful.
here in this view, it's a bit hard to see, but you can actually see the paths of the reflection from the radio emitter that I just put. So I'm going to filter it so that you can see it better. So I'm filtering for the radio, and I'm going to change the view so that it's from the top.
I turned to flee, and my sword swung on my belt,
focus on this.
deflecting the
Here we
poison.
go. So now it's from the top. As I move around, you can see the yellow and pink lines representing respectively the direct paths to the sound and the reflection paths.
Greetings, adventurer. I heard you'll be
And
venturing into the
what's
woodlands.
super nice about spatial audio is that you can have multiple levels of fidelity. So right now in this game, we have up from first order to fourth order of reflections. So I'm going to use a hotkey to switch to increase the number of reflections progressively, so you can hear and see the difference in real time. So please pay attention to the audio.
On my belt,
So this is
deflecting the
first
poison.
order. I'm going to switch to
With
second
luck
order.
and precision, you may also be able to deflect
And you can see the added reflections
Here
in
you are,
orange.
adventurer. One hearty pickaxe
Third order.
that has served me well when mining ore.
And
Greetings,
fourth order.
adventurer. I heard you'll be venturing into the woodlands. Word travels fast in these parts. You would best
Also,
be
I
careful.
forgot to show you the diffraction
there
around
yesterday to
the
gather
corners
wood
and the
for my
portal. So let's
smithy,
do that with
and the dark
fourth order.
plants had
So you can
already
see
luck alone
here
saved me.
the sound waves are not going directly. They are going around the corner here to my camera.
On my belt,
And this has an effect, of course,
with luck and
on
precision.
the filtering and the positioning of the audio.
Here you are, adventurer.
Obviously, this kind of fidelity can take its toll on the CPU, and not all games might have enough room to support that. So what we can do is go to go back to the main profiler view, and go to the CPU tab, so you can actually see the percentage of CPU that's taken for different parts of the audio simulation. So here, reflect is showing the percentage of the CPU taken just for computing the reflection. So right now it's sitting at around 4 to 5% of a game frame. And if I go back down to first order, it's back to about 1 or 2%. So that's another use for the profiler, is just trying to strike a balance between audio fidelity and performance. So that's about it for the demo. And now let's talk about how we made this work. And this is what I call reversing the connection. Because in every other platform that we support, this is the way this is done. So we have the game actually binding and setting up a UDP port and a TCP port and acting as a TCP server. And so the UDP communication is made for discovery. So the authoring tool is going to send a request via UDP on the network and try to detect every game instances running on the network. The game will reply via UDP, giving the TCP connection information, and then you can connect with the profiler using the TCP port. Obviously, this is not possible on the web for security reasons. You cannot bind these ports. So what we decided to do was set up a proxy server. So we prototyped something in Node.js for now, and it's working pretty well. It's a WebSocket server, so that when the web version is launched, it will connect automatically to this proxy server. And then from that time, every time that there's a BSD sockets operation that would normally happen, what it will do instead is wrap this BSD sockets operation in a descriptor JSON object, send it over to via WebSocket, and the proxy server itself is going to perform the operation. So it's a low-level abstraction. So in essence, the proxy server is binding the UDP and TCP ports. What's nice about this solution is that we didn't have to do anything to change the networking on the authoring side. The authoring side basically just sees the proxy server as the game, and that's it. Another thing that's nice about this solution is that if there are multiple instances of the game running, each one is going to have a separate WebSocket connection to the server, obviously. And the proxy server is going to manage the ports individually for each client connection. So you could have 2 tabs of the game running, and the authoring tool would still see 2 separate instances of the game. Or in a more likely scenario would be that you are sharing the same proxy server for your entire studio and every developer is using it. So with that, we have feature parity with the other platforms for the profiler. And as you saw, the proxy server did not add any noticeable latency. Obviously, the latency requirements for this are pretty low. So in essence, it worked out pretty well as a temporary solution. So in conclusion, some feedback about the development workflow. Coming back to web after a 3 years hiatus, we were really happy to see that shared array buffers is finally back. Audio worklet support is now rock solid across multiple browsers, including the audio worklet node. We were really amazed to see Dwarf support in the Chrome debugger. So for those who don't know, Dwarf is a format for debugging symbols. So we were able to actually break into our C++ code and step through our C++ code from the Chrome debugger. And we could even use it in the profiler of Chrome, so we could see which C++ function was taking too much time. Just amazing, compared to the printf debugging that we had to do in 2019. And also, even Unity support for WebGL is now very strong. So it was really easy for us to port the Wise Adventure Game project. And it just, except for the audio, of course, it just took us a few days of work, and it was good. Problems that we ran into mostly has to do with the tool chain, mild annoyances with the tool chain. It has a very aggressive linker pass, even more so than other platforms based on LLVM. So it was stripping our exported symbols from our DSP plugins. We basically could not use any DSP plugin until we put a hack in on the Unity side to generate C++ code that would use those symbols and force the linker to recognize that they are useful. That was an annoying hack. We also ran into a bad code gen for some of our DSP functions that introduced a high-pitched hiss on our low-pass filter. That was really not desirable. But of course, the real problem, as we saw earlier, is that we are not leveraging the audio worklet high-priority thread. because we want to focus on Unity compatibility, we are stuck. Unity will not allow us to do that. So that's a problem. But also, even if Unity did support exporting with a shared array buffer memory, there's also a problem at the Emscripten level where the generated JavaScript isn't necessarily compatible with the environment that Audio Worklet gives us. So Emscripten will always be able to generate a JavaScript file that can run on the main browser thread, on a web worker environment, and even Node.js. So these are all supported environments, but Audio Worklet is not supported officially. And sometimes it's using APIs that are not available in the Audio Worklet global scope. I've seen some people doing hacks at the link phase and post-link phase to make this work. But the problem is that we are middleware developers. All we can do is create libraries and ship them to people so they can use it in their game. So we don't control the final linking phase of the project. So those kind of hacks are non-starters for us. So it would be really nice if we could work together with Unity, the Emscripten team, to finally fix this problem. Because, yeah, real games need a high priority thread. We shouldn't have audio drop out when a game misses a video frame. But even so, right now, this is the state of things. And we do think that it's good enough for actual real world use cases. So I'm really glad to say that next year, we're finally going to ship support for web as a real supported platform. So also another thing I want to mention is that we don't necessarily need to wait this long to try this technology. Right now, since we're in the development right now, we are looking for partners to actually try this technology early in a real world situation. So real games, real interactive audio experiences. Doesn't need to be games. And we want to make sure that what we're building actually works for you. So yeah, if you're working on a game right now and you're looking to export to web, or if you're making a web-only game and you're using C++ or another native platform to do your development, just talk to us and maybe we can actually work something. But yeah, this is pretty much it. Thank you for your time, and I hope we have questions.
Thank you, Philippe. So Philippe was every week or nearly every week with the Web Audio Working Group. So he was part of the evolution also of the standard. So do you have any questions?
Those hacks and edits to the Unity engine that you mentioned, would it be possible to implement those as a Unity plugin or add-on? Is it?
Yes, we made those hacks as part of our Unity plugin that takes care of integrating the Wise SDK into Unity. So yes, if you have a Unity project, you'll get that temporary workaround automatically.
Yeah, thank you very much. It's always nice to have a demo of Wise. It's a great engine, and I'm very happy that Audio Kinetic is part of the sponsors of the conference. Now, apart from making your engine work on the web, which is great, yes, I'm still hungry. What is there any further thing that you think could happen together with the web audio community that is now possible, which is beyond having the web as another deployment platform for games you support? Is there any exchange you think will be possible in the future?
Yes.
Bits of code, concepts, and so on.
So I might have two parts to my answer. So the first one is that, yes, Audiokinetic is part of the community group that helps work with the Web Audio Working Group. And we do give feedback. And part of the feedback has been a lot about running like C++ WASM applications and making them run in Audio Worklet. And as I mentioned, there's still some parts that could be improved. So I think part of this could go all the way to the spec and actually making sure that, because we're not the only ones with this use case, right? So it's any audio application that is built on C++ or stuff like that are running into the same issues that we are. So we're hoping that we can help improve the spec to fix those use cases. That's the first part. The second part is maybe on a more immediate future is that so there's a part of WISE I didn't show because we don't support it yet on web, but we do support object-based audio on some platforms. So actually sending out separate audio signals as individual signals to a spatialization platform that's external to us. And we were thinking of doing that on web by using the 3D panner node of the web audio and actually have the positional, some elements being positioned in space using the panner node. So once we get there, might have more feedback about how to make this node more usable or stuff like that. Thanks.
Any other question? Yes.
Yes. Maybe I didn't understand anything, but at the end, you said you could not use the audio worklet?
I could use, Right now we are using the audio worklet, but it is pretty much wasted. All we do is copy a buffer. And that's the only thing we do as part of the process callback. We are basically taking the WISE application is going to generate a pretty large buffer that has higher latency, but still okay for games. So usually it's 4 buffers of 1024 samples, for example. But that's configurable, of course. And then the audio worklet node is just going to take this buffer and just take 128 sample chunks at every callback. So yeah, kind of wasted for a high priority thread, but that's what we can do right now.
I have a question. Okay, this is a commercial product, but we can use Unity to generate application and deploy them on the web. We can use it with my students. So for non-commercial applications, it's free.
Yeah, it's free to use. But even smaller projects, it's free to use.
And second question, I think I talked with that. I chatted with you a while ago. It's a shame David left, but my students are using Babylon.js. That is a web specialized library for making games and so on. And that is, by the way, I'm making advertisement for Babylon because my students love it and it's easy to learn and fun to play with. So my question that I asked you was, do you think it is possible to use this audio engine with such a library? I mean,
with Babylon.js, I guess that depends on the actual use case of the game. But my thinking is that it wouldn't necessarily be the most natural choice right now, because the WISE has a C++ SDK, right? So we don't actually export JavaScript, a JavaScript API. So usually it's more usable from within either a ready-made game engine that allows you to write C++ code or native code, and that's kind of the use case we're in. And whereas if you're coming from a game engine that's strictly JavaScript, you're not necessarily going to have a direct access to the WISE API. You're going to have to write a native shim to call the APIs.
Okay, thank you. So any other questions? Yeah, another one.
Yeah, thanks a lot. Besides the fact that the web could be a really nice platform for developing and pushing some new games, how do you think this could be also a way for inventing new scenarios between users? Like,
I'm sorry, I didn't get the question.
Yeah. Do you think that, besides the fact that the web is a new platform for you to develop and pushing your new games, what are the constraints for you and the ideas to maybe build something new between users for building new scenarios between them? Are there any things in the web that you could do maybe that you could not do natively? I mean, with all the web around and data, are there any ideas about that?
I mean, yes, but for Wise, it's middleware, right? So we're not actual an end user application. So we just give a tool to help other people build the end user application. But something like what you described, like connecting people together, and could be using Wise, but where we don't like, it's basically it's a sound engine that allows you to bind parameters that are controlled by the client to audio effects and reactions. So yes, you could use that to build something like what you described. Have I done an audio-only project? You mean using Wise or? Well, the closest thing we did was the integration demo, the text-based demo that you saw a screenshot of earlier. But if you're asking if you can use Wise without WebGL Canvas, yes, absolutely. It's just in the end, it's just a WebAssembly library that you can integrate however you want. Oh, actually, that reminds me, there was actually another internal project that never saw the light of day, but we did have at some point a prototype for a store, like an asset store, where you could preview the assets using the Wise Audio Engine, and that had no visual support. That was just a prototype that we did at some point.
Well, I don't know if some of you were at SMC 2022, but we had some demonstration of virtual instruments in using VR, written with Unity or written with the Unreal Engine. And the guy was also using some libraries for generating sounds and making effects. So I think this can be maybe applied also to something else than games, but things like that, or experiences with visiting, I don't know, 3D landscapes or whatever, or installations. Or
I mean, there's a lot of features I didn't have time to show, but yeah, there's a lot you can do with this thing.
So maybe it's time for a break. So you can talk with Philippe, drinking a coffee.
Yeah.
Okay, so
Doing
we
demos.
start in 15 minutes, 20 minutes. You go to the second floor. So you follow the orange jackets for the demos. If some of you are demoing, you can start going up, installing your setup. And thanks for everything, Philippe.
Thanks. Thank you.
Maybe a way to provide something back to the web audio community would be with the JavaScript API. Maybe and should be able to do that.
Yes.
Sending some messages over to your friend.
Yeah, it's I did think about that. I did think about that. Yes. Well, I'm not sure about all the capabilities of FMOD, but I know that there are more in the web space than we are. But the thing is that right now our API is very geared towards C++. So there would be, and it's very large. We're talking about hundreds of functions and many overloads for those functions. So I think it would be very difficult to have something that is automatically that automatically generates the JavaScript. It would have to be handmade, you know. So maybe we could have like a minimal.
No, but actually, I have this every time. We all think about it. Yes, and tomorrow is the like the bucket by the sea. Very complex.
Yes. Jordan, Peter, please.
Yeah, nice to meet you.
Okay, there are some people who want to play the guitar of the improvisation, maybe.
I can be a guitar player, yeah, but I don't know if my friends can play something like singing or.
No, but there are more people who want to play guitar. Maybe tomorrow.
I don't think. I'm just.
Tu as annoncé que après la pause, c'était à l'étage.
Guitariste. Yeah.
Yes, movies. You give me back the key after. Check the movie.
Thank you.
When is it? The